right up here?
I guess I'll put it here.
It's your choice. Yep. Okay. Just need to bring it up. You're our first presenter this morning? Okay.
That's not what I need.
All right, good morning. It looks like we've lost a few people to the cold and outdoors, so hopefully over time people will filter in. I think that was our experience last year. Maybe they are welcome if you're watching from the warmth of the internet. So we have a couple of paper sessions this morning and a panel, I believe. Our first paper session is on education. It was really important to the organizers of the committee that we had, or the organizing committee of the symposium, that we have something related to pedagogy, to the ways in which people teach data journalism or computation in a journalistic context, because that's something that I think the schools, at least, are still, to a certain extent, struggling with to get right. So, so we wanted to have a set of papers that, and we're in the call explicitly called for, asked for papers that were about how we teach. And so we have three excellent speakers today. The first is Cheryl Phillips from Stanford, and she has been running along with Charles Barrett, has been running a Knight-funded project to look at the kind of state of data journalism education, and I'm going to let Cheryl take over.
So we're still in the final stages of actually writing our paper, but I wanted to at least go through some of our top line kind of, I don't know, findings, I guess, and observations. And I want to start first with just with not with the slide, but with a little tiny bit of history, and that is that unlike some journalism education, data journalism actually started really outside of journalism education. It started in a lot of ways outside of the university. It started with a journalist, Phil Meyer, in 1968, covering the race riots in Detroit and doing social science analysis on the causes behind the riots, and winning a Pulitzer for that work. And then other journalists noticing that he had done something different using computers, and it made a good story. And then other people started trying to do the same thing. As that occurred, journalists started teaching each other. And then they started having conferences called computer-assisted reporting conferences. Such a clunky name, but it has stuck with us all of these years, and it is still often called that if it's analysis for story. So it was not until the mid-90s, really, that journalism education programs at universities started really officially teaching data analysis for story. And almost, and even then it happened rarely in just a few universities. They did start teaching other things related to electronic journalism. I took a class with something called electronic journalism in 1986 because the person who was teaching it was an employee at the Fort Worth Star-Telegram in Texas, and he had developed something called StarText, which was one of the very first electronic newspapers. You used a 300 baud modem with the acoustic couplers, and then your news would slowly go down your screen. And so there was the beginnings of that kind of instruction, and then later on there was some beginnings of how to build web pages and HTML, but the data journalism, the analysis, came a little slow to universities. And it's really been a kind of a newer development. So because of that, I think when we started looking at our programs, we were not all that surprised to find that the level of instruction is still has some room to grow, I'll put it that way. What we did was we looked at the journalism programs that are accredited through AEJMC, which is this accrediting body for journalism and mass communications, and as a way of just trying to take a good sample of journalism of university programs. And so there were 113 of those. We also collected upwards of 55 syllabi and analyzed those, and then we interviewed probably over 60 people, data journalism professionals, educators, and students. So what we found was that most of the classes, most of the universities, or a fair percentage, do not offer any class at all. That they teach reporting and writing and editing and multimedia, and nothing related to analyzing, nothing nothing at all related to analyzing data. So no spreadsheets, no basic, this is what a median is, this is what a mean is. That a lot of programs do require their students to take some kind of research-based class, which presumably would give them some of that basic statistics instruction. Generally, it's very much theoretical and not really based in trying to figure out how you would analyze things for a journalistic purpose. Then these other bars below are the number of programs teaching one class. So of 113, we have 54 teaching no classes at all, and then 27 teaching one class. This is for all types of data journalism. 3 or more universities, 18 universities teach 3 or more classes, which is pretty good, actually, in the scheme of things, and then 14 teach 2 classes. But that's for every kind of data journalism. So what do I mean by that? I mean that's what we call CAR, computer-assisted reporting, analysis for story. That's what we, data programming for journalism. It's not HTML and CSS, it's not web design, but it is data visualization. And it is something that we call emerging methods. So if you're doing something with drone journalism, if you're doing something with trying to do natural language processing, if you're doing something that's a little kind of pushing the envelope, then that's what we call emerging methods. And then we have another category called computational journalism, which is much more using things with algorithms, and I guess actually machine learning might fit in there better, but those are the categories. So if I looked at just computer-assisted reporting, this is like the very, very basic level of, you're going to use a spreadsheet, you're going to learn how to use a pivot table, you're going to learn how to use SQL, and just figure out where the story is. Then we have 63 universities don't offer a class at all in that very basic level. This is your introduction to how to use data for stories. And 34 universities offer 1 class, really drops off after that. We have 4 universities offering 3 or more classes, and there are a handful of universities who do quite a bit. So there's 12 who offer 2 classes. Those are in order. I'm not sure why they're in that order. I should have resorted it. But then this one is. So one of the other things we tried to get at is, well, maybe they're integrating the data journalism instruction. So we went through all of these courses, and this included emailing and double-checking the data with the universities. And so how many of them are teaching classes like reporting and writing with a component of data journalism with, we're going to give you a 2-week module on how to use a spreadsheet. And those numbers are a little bit better. So there are still 49 universities that don't teach anything. There's no class at all with any kind of component of data journalism. But then there are 30 that have at least 1 class with a component. There are 16 that have 3 or more classes with a component. And there are 18 that have 2 classes with a component. Data visualization is not represented well. And I think in part this goes to the point that a lot of journalists who are teaching in journalism programs are word people. And they're not visualization people. And so a lot of the visualization actually is coming outside of the journalism program. And you go to a design school for that, or a graphic design school, things like that. There's a little bit of it, but as you can see, not very much at all. It's just kind of a sad slide. The emerging one, again, really, really low numbers. So, and then programming, again, really, really low numbers. So what does that mean? That means that we're doing a little bit better than we used to at teaching the basics, but we're really hampered when it comes to trying to move beyond that to more complex analyses that will help us tell stories that are not being told otherwise. So this is kind of on the upside, the basic courses that are being taught. So when you are teaching that basic data analysis for journalism, if you look at the syllabi, they're being taught, really good concepts. They're being taught how to think about the data in a critical way, how to really check for validity and veracity. They're being taught, you know, the basics of spreadsheets, relational databases, some design concepts, even though there's not much in the way of visualization. The, you know, rudimentary kind of the basics of statistics, and a little bit of programming concepts. By and large, it's like it's a good, solid, the courses are good, solid introductory classes, and they get folks started. One of the criticisms that we heard from students was that they found out about these classes late, they weren't required, and they were already pretty far along in their student career by the time they even took the class, and then there was nothing else for them to take after that. So even if they kind of drank the Kool-Aid and said, oh yeah, this is what I want to do, then it was very difficult for them to continue in that learning capacity in the school, in the journalism school. They had to go outside of the school. They had to go to a traditional CS class, which doesn't really look at things from a journalistic perspective. Not that it's not a really useful class, but when you're trying to do both at the same time, it sometimes helps to have that journalistic frame. The other thing that we found was that there is a real gap in the textbooks. So it's interesting, I talked to the professor who taught me electronic journalism way back when in 1986, a week or two ago, and he said, you might recall that I had a really hard time finding a book. And I finally found, and he listed some book, I don't remember the name of it, and didn't recall that he had a hard time finding a book, but he did, and you know, it's the same problem today. If you look at this, there's a lot of different books, but there are really only 10 core books that are being taught in data journalism. And actually, the biggest category is NA, no book required at all. Now, this could be both positive or negative. I think that there are a lot of online readings, there's a lot of online tutorials, and there's ways to address that. But if you're thinking about really kind of diving deep into more of the concepts as opposed to the hands-on, the skill sets, there's just not a lot out there. So and so there's a lot of like things around the edges that are probably pretty good, but they haven't kind of trickled into the vernacular of how to teach this stuff. So those are kind of the main components that we've found. A few other just kind of points I don't have slides for, but when I was looking at this, fewer than 20 journalism schools teach any kind of programming beyond HTML. So out of 113 that we looked at, fewer than 20 teach any kind of program. So you don't know how to scrape a website. You don't know how to do anything in Python. It's just not there. And so that's just a really kind of important thing. And as we did this process, we did a lot of interviews, and I talked to a lot of folks who were relatively new out of journalism school, let's say in the past 5 years, and almost all of them said, oh, yeah, you know what, I did all my learning, I did online tutorials, I taught myself, I learned it at an internship at the LA Times, and then I went to the NICAR conference, and that's where I learned everything. And I didn't know about it until I was a senior. And so it's kind of it's just really new, the problem has not been solved yet, I guess is what I'm trying to say. The other thing that we discovered is that a lot of the faculty, there's kind of a conundrum. A lot of the faculty are either former data journalism professionals, like used to work at a newspaper, I used to work at a newspaper, or they're adjuncts, and they're still working at a news organization and doing this for not much money, part-time, labor of love, and because of that, it's not like a department-wide emphasis. It's like, oh, there's this one person who wants to teach this one class, and that sounds great, and you can be special topics. And there's not like a pervasive effort to try to change the entire nature of the programs to include data, despite the fact that our entire world is now kind of inculcated with data almost everywhere you look, and it's really important to be able to assess that. So why do we care? Why can't we just keep on going self-teaching and having folks learn through NICAR? Because one, I think we need the more pedagogical concepts as opposed to just the skills taught, and you get more of that in a journalism setting. That's one reason. And The other reason is that we're going to fall down as journalists. We're not going to be able to tell the stories we have to tell because more and more the stories that we have to tell are in the data. And we need to look at that data to be able to then follow those paths. And so, I mean, just from like the panel that we heard yesterday with the various journalists, I mean, it can become very complex to really be able to tell hard, nuanced stories that are important. It gets very complex very fast. And if all we're teaching is a smattering of basic classes, then we're failing our students and we're failing our journalism organizations. So those are just kind of our basic findings and opinions so far. And we're still, kind of finishing up the writing, but I just wanted to share the top line kinds of things, and I can answer any questions if anybody has them. Yeah.
I have a comment and question. First off, my comment is that in computer science, we actually do have a curriculum and courses as well, but they must change every 10 years, or even sooner than that. I'm wondering, Mike, I was saying, once you have journalists actually have a set of courses, there may be an issue of, okay, we're done, we have 10 courses, we have our whatever, and maybe when tech changes again, will it be a problem again to change things? Like, will you give the same talk 15 years from now saying, I can't believe that now they're still teaching this stuff?
So 8 years ago, the big push was multimedia. We need to be able to tell stories on a digital platform. And so everybody added multimedia classes. And now we have multimedia classes. Lots of journalism programs teach multimedia, but they're teaching tools as opposed to critical thinking about how to tell stories on a variety of platforms. So you get a lot of graduates who know how to point and click their way through, like how to build online slide galleries and things like that, but they still don't know the underlying, like how could you build something that would really last, And one of the folks that I talked to actually said one of the issues is that journalism schools have not necessarily always taught on mature platforms, and so then the technology changes and they're stuck, and then the people aren't equipped to move beyond that because they got the basic concepts into a different tool or a different kind of language. Flash is an example of that, right? At least they got something out of some, probably ability to do the JavaScript out of that, but it's still, there's actually, I found one program that still lists that they teach Flash. So, yeah.
Other questions?
Hello. I'm wondering, of the courses of the schools that you listed that have multiple courses, is there any analysis in there of how many times of how many individual faculty members or adjuncts, how many individual teachers there are of courses, or whether some of those are overlap of one person teaching multiple courses, things like that? Like how many professionals are there able to or teaching these kinds of topics right now?
We don't have hard numbers on that, but what we have through our interviews and observations is that it's usually one person in a journalism program, and then they're pressed into service in a multitude of ways, teaching a class, coming to guest lecture in other classes, and they don't have the time or resources to teach everything, and plus they're not equipped to teach everything. But yet, Steve Doig is an example. He's the night chair at Arizona, and he teaches a basic computer-assisted reporting class. But when he got there, he said there was a little bit of a tendency to say, okay, slot filled, and it doesn't really help with a curriculum emphasis. So, one of the things that we're suggesting is that there be a basic required class in computer-assisted reporting, and that then you could move beyond that into a variety of different tracks. Yeah.
And that basic car class is sort of spreadsheet based, or is it programming based, or is it?
We are flexible on that, but I think there would be for sure a base of spreadsheets, and then you could go beyond that. Virtually every person we interviewed, when it comes for like the professionals and the professors, when we said, what would you teach if you could only teach one class, they all said spreadsheets, including the programmers, including the developers. They said, you got to start with rows and columns and making sense of structured data and putting that into somebody's head, and then maybe you go into SQL. And maybe you teach a touch of Python, maybe, but that would be probably stretching it.
I guess I wasn't asked. All right, so anyway.
The majority, I'll say the majority, we'll put it that way.
I'm just teasing you. Other questions? Yes.
Hi. So in your opinion, how do you think that schools teach data visualization? Because the problem that I'm having is I scrape the data from the websites, but I'm not able to represent in an interactive way to engage the audience. So what do you think that?
So, well, I think a couple of things. I think you can include a little basic data visualization in the core CAR class. So, and you do that not through teaching D3, but you do that through teaching things like, why is a pie chart bad in most instances? You know, when do you use a bar chart? When do you use a line chart? And this software that I use for this is Tableau software. It's based on a visual query language. You can get into the guts of it, but it's a very point and clicky thing. I don't recommend teaching a tool, but you can explore data visually in that, and you can build presentations in that, and it's not a bad, very intro tool for that purpose. Beyond that, I think you've got to partner with design schools, because, you know, the graphic designers at newspapers, for the most part, got their instruction in graphic design schools. And they went into newspapers, and they are the experts in how to present information in a visual way. So it's not the editors and the reporters who can teach that. It's the folks in graphic design who can help teach that from that journalistic frame. So Dave Stanton, who created a site called For Journalism to kind of provide some screencasts and videos for data journalism, like building Django frameworks and doing different kinds of things. He actually came up with an idea of scaling across universities. I mean, I've just talked to him recently, and he was saying, look, if you have an Alberto Cairo in Florida, then why not have him do some screencasts on how to tell this journalistic stories visually, and then you can give assignments that would be specific to a project in your school, but you kind of share the resource of an Alberto Cairo. If, you know, it's an interesting idea. I don't know that anybody's contemplated it up to this point, but, you know, not everybody is going to be an expert in that, so.
I guess I had one last question. Was there any, did you ask about sort of the interest level or the skill level of the students coming in? Like, are we in this moment because the students are requesting this, or because the newsrooms are requesting this, or because the schools are requesting this?
Well, the newsrooms are definitely requesting it. So Brian Boyer works for NPR and is a programmer and has done a lot of different things in journalism, and he just recently went on a huge Twitter rant about how he, using a lot of expletives, about how he couldn't find the people he needed, and he kind of blamed newspapers because they weren't helping their staff expand, but he mostly blamed universities for not teaching students and not giving them the skills that they needed, so that he couldn't hire the people he wanted to. So I think the industry is demanding it, and there's a huge market for people who have these skills. But on top, and I think some students, if they know about the possibility, are demanding it. But then on the flip side, I had a couple of professors say, well, yeah, we used to teach computer-assisted reporting, but we didn't get enough interest, so we don't anymore. But I would probably contend that they didn't get enough interest because of the way they were framing it more than anything. So that's just my bias.
All right, other questions? All right, let's thank Cheryl. All right, next, Susan McGregor.
Actually, I was just going to grab my phone, too, sorry. Come on. Here we go. Oh. There we go. Okay, Cheryl provided a great segue for me because what I'm going to talk about is actually strategies for actually teaching technology to journalists. And specifically in this case, I'm talking about the courses that I've taught here at Columbia Journalism School for the last 4 years, which is a 7-week data module, data journalism module, and a 14-week data visualization class. And in both of those courses, I teach programming. So in the 7-week data module, I usually do start with spreadsheets and kind of move into basic Python for data analysis, regular expressions, and a little bit of web scraping and data transformation. In the spring 14, which is a 14-week course, I end up teaching primarily JavaScript for the purposes of using data visualization libraries, and a little bit of HTML and CSS, although it's very secondary in this. So this is something that I thought a lot about before I came to Columbia. I was a senior programmer on the news graphics team at the Wall Street Journal for 4 years, and my master's degree is actually in educational technology. So as an undergraduate, I started out studying computer science. My observation about the way that programming was taught in a lot of undergraduate computer science programs was that it was not taught. You sort of talked about concepts in class, and then you kind of got a textbook and a computer, and you slogged your way through however you managed to. And so I thought a lot over the years about how one might teach programming and programming concepts, especially to people who were not going to specialize in it, because in the end I was more interested in information visualization, and so ended up moving out of computer science, the sort of formal major, into a hybrid major that I designed that added things like cognitive psychology and visual design. So this is something that's very dear to my heart as a topic. And there's been a lot of debate in recent years. I think Cheryl's work and the Knight Foundation's work is really indicative of the interest that there is in this. But this is just a sampling of some articles over the last few years about whether or not journalists should learn to code or whether they should learn to program. I mean, even the fact that we don't necessarily we're not agreed on what exactly we're trying to teach, I think is indicative. And this is actually from just a couple of months ago, and this is sort of why journalism students don't learn CS, and this is someone who is looking at journalism students taking computer science courses in particular, which is that they don't know they should, which I think Cheryl's stuff analysis reveals. They think they'll fail and they don't think they'll enjoy them. And so one thing that I would say is that, as somebody who spent some time in an undergraduate computer science program, here at the journalism school, we actually have, and I'm part of the Tao Center for Digital Journalism here, and we do supervise a dual degree in computer science and journalism. So we have students who enter the school, they take classes in both the engineering school and the journalism school over the course of 2 years. They receive an MS from both schools. And so there is room for genuine computer science and journalism for that kind of joint education. And there are a lot of things that folks with that background are going to be able to do. But for your sort of, for someone who is still primarily interested in reporting, who is maybe getting a sort of more straightforward journalism degree, I wouldn't necessarily advocate computer science. There are a lot of things that formal computer science teaches that, frankly, in my experience, are not that relevant to the kind of work that we as journalists do, especially because of the size of data that we typically use and the fact that we mostly work on the web. So I would say not necessarily computer science, but scripting, or programming or coding or whatever you want to call it. And of course, the reasons for this are several. One is independence. In the last few years, a lot of the tools, there are an enormous number of tools and services out there that do things that we used to have to write code to do. So there are services that you can, point at a table on a website and it will scrape it for you. It used to be that you had to, bust out your Python and your beautiful soup and go do that yourself, right? So there are a lot of services that can get you pieces, can get you parts of the way. But of course, if you understand the fundamentals of what they're doing, then you have a much greater independence. So when you encounter that corner case, you encounter that thing, that data set that doesn't fit whatever sort of pre-formulated types are supported by those tools, you still have something that you can do about it. Critical evaluation skills are key. I think changing the way that we all, and journalism students are the main audience in this case, the way that we think about technology. So this goes from everything to thinking of ourselves as programmers, as people who can manipulate technology, not simply use it or interact with it, all the way over to sort of things like algorithmic analysis, which is not part of what I teach, but I think involves kind of a shifting of mindset for a lot of folks from consumer to creator. Again, flexibility, and at the bottom line, just literacy, right? Being able to do being able to look at the source of a web page and not go like, or oops, or go to, understand what an API is and how that might, involve material that is useful to you. And that even if you're not the person who can do it directly, that there are people perhaps in your news organization or people that you can locate for whom that is a viable source of data and information, right? Being able to parse that. So challenges to teaching technology, and I'm just saying technology here to encompass things like scripting and data analysis. One is self-concept and stereotypes, and I'll talk about this in a second. Another is the abstractness of this. This is something that I think is a challenge in general in teaching programming, because a lot of times we're dealing with invisible systems, right? You type things into a box and then something comes back. We don't see those things happen the way that as you compare to the physical sciences. Even if you have to do some weird, some seemingly nonsensical mathematical formula, like you can watch a ball roll down a hill in physics, right? Like you can see some of the tangible output of that. And scalability is a really big problem. How do we actually teach these things in such a way that we can do it to more than a handful of students at a time, because they can be very intensive, especially when you're dealing with adult learners, as we often are in these cases, right, undergraduate and graduate. So self-concepts and stereotypes, this is actually how I begin every single class I teach, the very first day. And for those of you who aren't familiar with this, Program or Reprogrammed is a talk that Douglas Rushkoff gave many years ago at South by Southwest. It then became a little book. There's a part of this, of actually just the introduction to the print version. I've checked and it's actually not in the online version. But essentially one of the things that he does is and this is always, it gets more amusing every year, the number of students who have or haven't seen the movie Driving Miss Daisy, which is the metaphor that he uses in this, which is this idea of learning to drive. And basically that if you want to be able to determine where you go in the digital age, then learning to program is essential, right? Otherwise you are being driven around by somebody else who designed technologies that you're using, and you don't get to choose where you go. So I find this a really interesting starting off point, because on the one hand, driving is actually a complex task, but it differs a lot from programming. One is that, so it's a complex task that most of us feel ourselves equal to, even if we don't actually do it, right? Not everybody drives, but most of us kind of feel like we could probably learn to drive a car if we wanted to. But there are differences, and one of the big differences is that driving is something we see happening all the time. Right? You walk out on the street and you see cars going by, you see trucks going by. It happens in your life all the time, right? Programming is not that way. We see finished products, right? We see things launch in the App Store. We hear about, big venture capital deals for people who create apps, like that's how we encounter it. We don't see the guts of it. The other thing is we see lots and lots of different kinds of people driving, right? We see older people and younger people and men and women and, people of all kinds of different, different demographics and ages and abilities and all of this stuff. We see all kinds of people drive. Again, programming is largely invisible, and mostly the people who are made visible to us fit a very distinct stereotype, right? And they are presented in a certain way, especially these days. I always like pointing out that undergraduate enrollment in computer science in the late 1980s was actually 50%. It was actually a 50-50 split between men and women. It's in the last 25 years that it's gone down to the 90-10 that it basically was even when I was an undergraduate. And I think a lot of that has to do with the optics, right? It is now presented as a certain kind of person who does that. So a lot of this is just really directly saying, do you think you can program? Why do you think you can program or not? What is intimidating to you about this? And kind of engaging those things directly. So that's literally the first discussion every single class session, every single semester for me. But the other thing is pointing out to journalism students that they are strong with language, right? And that actually programming languages are languages, right? They're not about chipsets and and bit switching, right? That's not how we actually engage with them. And so I really like this one, especially because we, here at Columbia, our primary language that the language that we're teaching and working in is English. And so I love this poem, right? Which is, beware of herd, a dreadful word that looks like beard and sounds like bird. And dead it said like bed, not bead. For goodness sake, don't call it deed. Watch out for meat and great and threat, then rhyme with sweet and straight and debt, right? English is an enormously complex and difficult language. It is nonsensical. And anybody who's learned it as a second language can attest to this, I think, very directly, right? It's hard, right? Programming languages, by contrast, are extremely small and extremely regular and extremely simple. So this is my favorite Venn diagram, which is like a natural language is enormous and complicated, and programming languages are tiny and small and simple, right? They're very, very well defined. So if you can do English, you can definitely do any of the programming languages that you're going to encounter, especially as a journalist. So this is an example of I like teaching JavaScript as a natural language. I take an example of a story. This is a couple years old, but it's a story about Piers Morgan, who's a celebrity in the UK. And then I basically just pull out pieces of it and start translating them into JavaScript, right? So Piers Morgan is an object who has properties. We have functions of how he's been interviewed. We can execute the function on him with arguments that are, police and Piers Morgan. I won't go through all of it, but, we do things like we can modify him, we can add properties to him. In the course of one 300-word story, you can find examples of every kind of data structure that you are going to need, right? You're going to find every simple data type. You're going to be able to add in the complex data types. And the truth is there aren't that many of them. There's actually not a lot of quote-unquote grammatical concepts in programming languages. I usually count about 5. So once you get on board with that, you're pretty much good to go. And those will translate in one form or another across most of the languages that students are likely to encounter. So the other thing I want to talk about is scalability. And this is where the videos come in. So as Charles was mentioning, so the flipped classroom in sort of general parlance tends roughly to mean that students watch video material before they come to class. And class is more like kind of doing the homework. And that's pretty much it. I've been doing this now, I've been doing this since I started teaching here. I've been doing this for 4 years. And what I do is I make a series of videos, and I literally just sit there and I do the assignment and I just narrate. I just talk to my computer. And there are a whole bunch of reasons, and if you read the paper, there's a lot of reasons why this works. One of them is that it's actually it's much more efficient for me to produce these. I tried once doing a guide to like a segment of like setting up a web page my first semester teaching my visualization course, and it took me 6 hours. And I was like, very quickly, I was like, this isn't gonna work, right? I can't do this every week. It's usually about time and a half or twice as long to make the videos. I tend to make between 30 and 50 minutes of video a week, up to 10 to 15 minutes a segment. And just go through it. Students watch it before they come to class. We do principally the same activities in class. And then generally their assignments consist then, again, still of pretty much the same activities, so they can use the videos as reference, but usually with some important transference tweaks, like they have to give unique names to their variables, for example. They have to rename all of the things. So they can't just do it rote, but the fundamentals are going to be covered. Commenting is also a really important part of it. So some advantages of segmented on-demand video. Students can better direct their attention and questions in class. You are going to be introducing new software. If they've seen it before, it's easier, right? It's not like, wait, where's that button that I'm supposed to click on? They've seen it before. They've encountered it before. If they're a little bit more advanced, then they can ask some more complex questions, right? Because they've been able to absorb that material. They can review material as needed. The first stop always is the videos. They can go back to the videos. Virtually everything that they need is going to be there. But the fact that they can do that also dramatically reduces their anxiety in the classroom, right? People, they feel reassured that if they miss something in class, there's going to be opportunity to go back and look at it later. And anxiety is like a death knell for learning, right? People who are anxious, we know this, people who are anxious, they narrow their focus, they have trouble solving problems creatively. It's extremely important to sort of help make sure that students are comfortable. And production time, again, for the videos is minimal. It actually is important that they are a low production quality. It's really good to make mistakes in front of students. This indirect learning, a lot of programming is about error recovery, right? So modeling how you recover from errors as an expert is a really, really valuable instructional tool. Again, it reduces students' anxiety, but also it gives you a chance to model different ways of solving problems, and that's really what you need in order to succeed with this. And finally, questions that are unaddressed in class can be integrated via additional videos. So if something comes up, someone brings up a point that you really don't have time to delve into in that class session, again, it's really simple to just, quickly go on and make another 5-minute video and say, hey, this is what came up in class. Boom, you're done. Upload it to YouTube, add it to the playlist, and you're set. So that's all for me. Yeah, if there are any questions, I'd love to have them. Did I make it? No questions.
Yeah, hi, thanks. I did want to say, so there's a lot of pressure at computer science departments now to manage a lot of the issues that you're talking about, both around scalability, obviously, but also diversity and the issue of sort of reaching out to the broader university community. I can speak personally to this, and it's probably true at almost every computer science department in the country that there's a strong sense from both within the department, from students, and from higher up that we ought to be reaching out more to other disciplines and sort of trying to figure out ways to actually teach programming in particular, but computer science concepts generally to larger segments of students than just people who are going to go on to become professional developers or get PhDs or something like that. So I think there might be some hope for being able to find some help in other parts of the university going forward, maybe more than there has been in the past.
Yeah. I mean, I would just add to that, I forget which, there was a program that did this, and I unfortunately can't remember which one it was, but I think the question of how the problems are framed is huge, right? So I think one of the things that acts as a deterrent for a lot of folks is that even introductory programming courses are talked about as like, it's computer science, and a lot of people, it's like that's not necessarily a primary interest, but programming is problem solving. Right, and I think that the thing that I've found is successful and that I think has been demonstrated in other programs is that if you anchor the concepts in in relevant problems, like even with math education, we see this, right? Like it's like you can teach somebody to you can teach somebody division, or and then you can frame that as, okay, here's how you figure out what product is cheaper by the pound in a supermarket. That sticks with people. I mean, grounding things in concrete experiences does a lot for all kinds of math and science learning. And so I think that's just something that as we bring that more into programming, I think we're going to see more interest and also more success from non-specialists.
Susan, this is great, and actually it's good to have people like you who have thought about education, computer science, and journalism to be doing this kind of stuff. So kudos for that. A couple of interesting points that for us as a community we should be thinking about. Are there online resources we should be making available to each other to start kind of thinking about developing it? And again, I do not know, this is a controversial term, but online education is kind of coming in its own in different ways, may not have gone to the level everybody thought it would. But one of the examples I give is large number of the people in the world have started learning machine learning because Andrew Ng put a course online, and anybody who knows linear algebra and all that kind of stuff can jump into it. Now, of course, not everybody knows linear algebra.
Including myself.
So, so that's the kind of stuff that actually is happening out there. Just as a note, I'm about to be developing a computational journalism course that's going to be online soon too. Of course, it's going to assume you need no programming and a little bit of a math. So, we have to start figuring out is how do we kind of create a pathway. Now, not all those resources might be available at each and every university because that's the nature of the beast. But can we actually create pathways that could start leveraging modules from different units using Alberto Cairo's courses that he's been putting online for these types of things? And any thought on kind of creating these, I would almost refer to as ad hoc, but not really ad hoc, pathways that actually take in, saying, hey, you learned this now. For example, you could learn linear algebra by going to Gil Strang's classes. The videos are available for that too.
Yeah. No, I think it's great. I think, again, the thing, and this is something that as a programmer, both at the Journal and I worked at a startup prior to that, was that, so I did come primarily from a computer science background in my approach to programming. I think one of the real challenges, but I worked on design teams. I always worked on design teams. And one thing I learned is that engineering is general and design is specific. Right? So when you create an engineering solution, you want it to be as general as possible. And when you create a design solution, the best solution is one that will only solve that problem. And so I think that there is opportunity to find pieces of concepts that can fit together. I think the challenge really, and this is one thing I think for Cheryl that I was curious about, is I think the other thing is thinking about the pipeline of instructors. Who can we get to teach these classes? And I think the challenge is finding people who have, in any particular field, the subject matter expertise, who can identify what the relevant problems are and say, oh, this is a problem that needs solving in my domain, and then help them get the understanding to go, oh, and here's a tool over here, here's a concept that could actually be applied to it.
So the other thing which you said also, I think, which should resonate with this crowd, I hope, is putting programming in context is extremely valuable.
Yeah.
And again, there has been a huge push in computer science on both sides of the spectrum. There's been an attempt which was referred to as computational thinking, When you go to a grocery store and see a queuing line there, well, that's queuing theory. Learn from that. But on the other hand, there are computer scientists will tell you that first learn the abstractions. Because
Of
once
course.
you learn the abstractions, I mean, it's an
That's because
argument
that's how they learned it.
and then again, it's two ends of the spectrum, and there is actually more and more. And again, again, I can speak for Georgia Tech. All majors, not just computer science, not just engineers, all majors, even architecture students take programming.
Yeah.
And it's
Yeah.
the kind of new thing that started happening, which might be valuable.
Yeah. I don't know if we have time, but there's.
Yeah, just one more.
Thank you. This is great.
Hi. So one of the things that I think that journalism schools are probably struggling with that I wanted to bring up is the hiring of people who can teach these things. If you don't actually understand programming, how do you tell that someone you're thinking of hiring actually knows their stuff? Do you have any thoughts on that?
Yeah, I think it's a really big challenge, and we saw this a lot in early years because, in my first years here, because we'd see job descriptions, and it would be like, and it's like we want, it's like the unicorn, right? And so as somebody who does understand these things, you could read, very often you could read job descriptions, and you'd be like, oh, they have no idea what they're looking for, right? Because it was just a a kitchen sink, right? It was a bucket list. I think that. I think some really traditional things is like ask them to explain something to you. I think if you're talking about hiring people for teaching positions, right? Yeah, I think in that case, I would say ask them to give a sample course, invite them in. I actually, before I joined Columbia, I did a sort of handful of drop-in sessions down at CUNY, and I think that, you can very quickly see, make the interview a sample class, and just see if that person can teach you anything. I think that's a really good place to start. That's it. Because again, the challenge with education is that being a subject matter expert does not make you a good teacher. In many ways, it can work against it, right? It's a challenge because you have to be able to think through the things as a novice would. And if you know it really well, that's helpful in some respects, but can also be challenging. That's one reason why also, I always try to teach with an adjunct who is sometimes less experienced than I am, or less of a formal programmer than I am, but also who's working in a newsroom. Because to a point made earlier, I revise my material every single year. Every single year, I talk to people who are in the industry, and I'm like, all right, what are y'all doing now? And the ways that I built things and executed them when I was at the Journal, also the Journal is a large news organization, it's distinct from smaller ones, what we're gonna use. I change things every year. So I think that's, those are a couple of things that are really important. So people who are doing it in the newsroom, I think, are also gonna be a little bit better at that. So thank you very much.
All right, our last speaker of the session, Meredith.
All right, where's the plug? Here's the plug. It is not. All right, hi everybody. I am Meredith Broussard. I am an assistant professor at NYU, and I have been teaching data journalism for a few years now. And I've taught data journalism at two very different institutions. I'm now at NYU, and I was at Temple before that. And what I'm going to talk about today is I'm going to talk about the back end of teaching. So my paper has the slightly formidable title of Teaching Coding in Journalism Schools, Considerations for Secure Technological Infrastructure. But what I mean is I want to talk about things that we can do to better support the teaching of data journalism on a logistical level. So data journalism, I always describe it as the practice of finding stories in numbers and using numbers to tell stories. And we teach data journalism very differently than we teach straight computer science or we teach straight journalism. So the first thing I discovered when I was about to go into the classroom for the first time teaching data journalism is I realized that the number of things that I could possibly teach is really vast. Okay, so Cheryl alluded to this before. The choices of what you put into your curriculum, like there's no core set of skills, there's no core set of concepts in data journalism or computational journalism because it's still too new, okay? And you do have the question of teaching skills versus teaching concepts. So what do you put in? It's a good question. What I decided was that I was going to start with spreadsheets. I was going to move on, I was going to teach spreadsheets through pivot tables. I was going to do some basic data visualization using Tableau. I was going to do SQL if there was time. And then my classes always end with an independent project where the students can leverage all of the skills that they've learned so far, but they can produce a piece of publishable journalism at the end using all of these new skills that they've adopted. So one of the first surprises for me was that these are the people in the room. My students were an unbelievable range of students. They had a lot of different experiences, and some of them were on the far side of the digital divide. So this is something you encounter in journalism schools and you don't encounter in computer science departments. Journalists tend to have a lot of math anxiety, right? You know that joke about, oh, I'm a journalist because I don't like math? Like, these are the people who are going to show up in the digital journalism classes, okay? So it's important to meet the students where they are as opposed to where we think they ought to be. And so one of the things that I start my classes with is I start with, okay, this is what data is. Bless you. And data is socially constructed. Data is assembled by people counting things. Okay, so I do a lot of things, as Susan mentioned, to mitigate anxiety, mitigate math anxiety, and then also to build computational literacy, because the students haven't necessarily developed computational literacy. And they also are not necessarily comfortable on different platforms. Another surprise to me was that these are the people in the IT department. Okay, so in computer science departments, you can depend on most people understanding what a web server is. Most people have done some programming. Most people have dealt with the command line. This is not the case in journalism schools in the IT department. Okay, so the support that's available to professors around instructional technology is totally different in J schools than it is in engineering schools and in computer science departments. Now, I don't necessarily think this is a good thing, because I think it's really important to have a collaboration between IT and professors so that IT can support the professors' teaching in the classroom, and the professors can make sure that students take advantage of all the resources that are available at the university. Another consideration in the classroom is FERPA, okay, the Family Educational Rights and Privacy Act. Now, FERPA protects the privacy of students' educational records, but one of the very ambiguous things that we've never really worked out in all of the years of this legislation is what exactly are educational records. We're still not sure. So, as a professor, I like to use university resources, university computational resources whenever possible, because of FERPA, but also because it's easier for the students. The students know their university IDs, and when they have to get an outside account, so some of my colleagues kind of get around the issue of missing technology infrastructure inside the classroom by having the students go out and buy their own web hosting account for the semester, and they say, okay, we're going to teach you to build some web stuff, but you need to go and buy your own Bluehost account or your own, one-in-one or whatever. And I'm not comfortable with that because it's outside of the university purview. I also think it's too hard. All right, so for the students who are coming into my classroom who maybe haven't seen HTML before, or they don't really know what a web server is, I think it's too difficult to ask them to go and buy a web hosting account and upload their stuff and deal with all the administration. So when you think about scaffolding learning skills, that's not where they should be starting. They should be starting at this place where I'm providing them with a web server that they can get familiar with, and they can understand this is what a web server is in the first place, and this is what basic HTML is, and hey, let's use an FTP client. All right. So with all of these things in mind, I wondered, all right, what am I going to do? So I want to talk today about two solutions that I came up with for teaching data journalism skills, but also for teaching them inside the umbrella of the university IT infrastructure, which is not as easy as it sounds. The first thing I came up with was a WordPress solution. Now, lots of people in journalism programs teach WordPress. Lots of universities have a WordPress multi-site installation where you can just go with your university ID and click, I need a new WordPress site, and then you've got a site, and then you can kind of put some stuff on it, and voila, you have a web page, which is great. But it's not really very useful for teaching advanced journalism concepts because in those sites, the students are typically locked out of any administrative access. So you can't teach, this is a plugin, and this is how you install a plugin, and wow, you have all this additional functionality, because you're not allowed to install plugins, right? There's no, WordPress has these different roles, right? You can be an author, you can be editor, you can be an administrator, but in the typical university multi-site installation, those roles are not available. Right, so then you're back to, all right, well, you make the students buy their own hosting account and install WordPress on it. Well, again, it's too hard. Not that WordPress is difficult to install, but then you run into the question of working in public, which we love in the open source ideology, but is actually contrary to some things that we teach in journalism. Journalism is a discipline of verification. We teach journalism students, don't publish until it's been fact-checked and until it's right. We teach them to be first, but be right, and it's better to be second than to be wrong, okay? However, when you are working with data, you're often wrong. Okay, and that's really good in terms of the learning process. I want my students to write a story based on data and do the analysis and be able to screw it up and be able to bring it in, screw it up, and then we talk about it and they fix it, and that's a really important part of the learning process, right? But if I'm asking a student to write this story that is probably going to be wrong, and I'm asking them to publish it in public, like, that's not right. Okay, that's against principles of journalism. We also wouldn't ask students to do that in a calculus class, for example. In calculus, you do a problem set, and you get things wrong on the problem set, you bring it in, you correct them, and you learn. Okay, that's the process. But you do it in private. We're not asking calculus students to publish their problem sets in public saying this is correct. No, we're giving them some privacy. So I think journalism students deserve the same privacy for working on data stories. So my idea was I want to create a walled garden where the students can fail safely, they can be wrong, they can put their stuff up on the web, all right, so they can have the practice of using a content management system, they can have the practice of integrating data analysis and weaving together story and code, but I'm not saying you have to have this perfect on your first draft. So because the university didn't have a multi-site installation that allowed administrative access, I actually asked around a lot, and I found this other multi-site WordPress installation at my university, my former university, where I persuaded the webmaster to make my class a special site that was password protected and had a larger range of plugins than was typically available. Okay. The reason I had to do this was just complicated reasons having to do with IT, which I will get to in a second. Okay, so different multi-site, different WordPress just for my class. It helped that one of the students in my class was working as a work-study student at for the web administrator, so it took a lot of the administrative burden off of this guy. So the password protected part of it was key. The walled garden approach was key. So the second solution I want to talk about is for teaching more advanced concepts. So one of the things that I want to do in my more advanced data journalism classes, I want to teach the students how to develop news apps, and I want to use Django. So in order to have a news app in Django, and in order to do it in the classroom, you need a central web server. All the computers in the classroom need to connect to a central web server in order to put up their code and be able to see it working. All right. The computers in the lab are an important thing here because there are two schools of thought. You should use the computers in the lab to teach versus you should make the students bring their own laptops. Now, at Temple, the students have a very wide range of economic diversity, right? So I had students who were on food stamps. I had students who their primary machine was a tablet because it was less expensive. And it seemed wrong to ask these students to buy a $1,000 machine just so they could learn in this class. I mean, that's not making education accessible to everybody. And so the university has already thought about this. They've already made these computer labs across campus. They have 24-hour access to the computer labs. I can teach in a room where everybody has a really powerful computer and everybody has the same software on it. So I want to take advantage of that. However, university computer labs are different levels of lockdown. All right, I was teaching in one that was totally locked down, and you couldn't SSH out anywhere except for this one web server that nobody was really allowed to do anything with. So that wasn't really helpful. So I needed some sort of way around that. I didn't actually figure it out at Temple because I got this new job. So now I did figure it out at the new job. So I need this in order to make this. So this is the news app. We've got the database layer, the application layer, and the presentation layer, which at most organizations is split into, the presentation is usually split into a CMS and a something else, because most news app development teams actually develop their work outside of the organization's CMS. So that's why starting with WordPress is really helpful, because it teaches the students, okay, this is how you work inside a CMS, this is how you hack the CMS, and now this is how you do stuff that is even more elaborate than working inside a CMS. You can roll your own. All right, so I need that in order to make this, but then I also need this. All right, I also need a production environment. I need a development server, a test server, a staging server, and a production server. Because at a large news organization, you're not going to develop on the same place that you have your production code. Like, nobody does that, right? So I need to simulate that for the students, because if the student is taking my class and they're going out and they're being the only coder at a news organization, I need to teach them what are best practices, because nobody's going to come up with the idea of having a development server and a production server on their own. I mean, you're just not going to. So whenever I say, oh, I want to give students administrative access to a development server, to an IT person, they always freak out. And they always say, well, what if the student wipes everything out? What if the student deletes everything on the server? I can't possibly give a student root access to anything because the student could delete stuff. And I get that. But from my perspective, I'm totally happy if a student goes in and wipes out the computer, okay? Because that's a really important learning process, okay? And it's really fun. I mean, have you ever wiped clean a computer? It's kind of great, right? Like I used to have this job on Wall Street where like I taught server administration, right? And like part of my job was my friend and I periodically had to go in and like wipe this whole room of computers. And it felt really powerful. You know, like that's how I learned that, yeah, you can wipe it clean, then you put it back, and then you like build it again, okay? I cherish that for my students. IT people don't like that. So I came up with this thing where we're gonna make an AWS, we implement this in AWS. We make one of these pods for each of the students. The administration of it is handled by IT on an as-needed basis, and that is our pilot. So that's how we're gonna do it next semester, and we're gonna see how it goes. Okay. So just to summarize, so two solutions, two of the many, many possible solutions for the back end of teaching data journalism inside a university environment. So obviously there are considerations inside the university that people working independently do not have, but I'm a professor, I work inside a university, I have this wonderful infrastructure, I have all these extra considerations, and how do we design something that works inside that? Okay, thank you. All right, questions?
I just want to say kudos because I have to say that I think, first of all, taking the privacy considerations into account, but also the fact that, I mean, I worked in a news organization where we didn't have this level of sophistication for a long time, but it is really important. And I think that, again, that idea of, you know, students being able to screw up, right, and screw up in private. I mean, that analogy, this idea, I think the idea of open and visible programming is valuable in being transparent about work. But yeah, we would never ask students in other contexts to do that. And also just to say that yes, I've had the opportunity to drop a production server accidentally while at a news organization, and it was fun in its way. So
yeah,
thank you.
Yeah, one of the things that was interesting to me about this was that the idea of having a development server and having a production server, like this is a non-issue in other disciplines. Like in software engineering, like you guys have figured this all out already. Like you have best practices, but then at news organizations, we're still struggling to figure this out. So at the university, like why can't we just take the best practices from established academic disciplines and teach those at the university so that the ideas can percolate out into industry?
All right, thank you very much.
Okay, thank you.
I'm going to now hand the mic over to Nick Diakopoulos for the next session.
All right, so if you're in the next session, please find your way to the front here. So up next we have opening the process. We have three papers from our solicited program. And up first, we have Chris Kasanovich and Regina Roberts. I'm Nick Diakopoulos, by the way. Okay. So they're up first with no data, no computation, no replication or reuse. The utility of data management and preservation practices for computational journalism.
My dongle.
Good morning, everyone. So thanks to those who put together the order of presentations this morning, because talking about best practices and curricula for journalism schools, I think what we have to say and present today really dovetails nicely into it. And hopefully we can talk to some of the faculty that are in this room afterwards to see, can we help you create a module of what we're talking about for your students, because we think it's very important. However, we also realize that we're also speaking to journalists in the field as well as academics and students, so we tried to kind of gear the presentation to cut across all those lines as possible. So we're trying to present some best practices. I'll just point out this mouthful of a title. I told it to our web archiving manager, who gave me this, "Oh, that's so sad." And I was like, yes, the doom and gloom makes a point. It drives it home. So, and you could probably substitute replication for verification, since in this community of practice, that is paramount. And so with that, I'll just say I'm Chris Kasanovich at GovInfoGal. I'm a librarian, and I'm wearing my metadata shirt in homage to a lot of what we're talking about. And I'll let my co-presenter introduce herself.
So good morning. Hi, I'm Regina Roberts. I'm also a librarian at Stanford. I'm the subject librarian for anthropology, sociology, journalism and communication, feminist studies, and Lusophone Africa. But today, Chris and I want to emphasize the importance of data management, and especially the archiving and preservation of your data for future use. And I also want to say that we recognize the changing nature of research, and libraries and librarians are expanding their roles to help you find data, archive your data, and data management plans.
So we've presented a model here, and I'm glad that Nick is here, because it's actually, as we were going through the various literature, we actually started this concept. We'd seen a Urban Institute presentation about government open data and this discussion of big data behind policymaking, and we asked, okay, but what's the role of the librarians? And Regina, being in communications and journalism, the liaison librarian for that group, we started digging into this body of literature. And so it's actually what he calls a process perspective of journalism in the article, A Functional Roadmap for Innovation in Computational Journalism. So it's basically that information gathering up to dissemination and public response totally resonates with us in terms of information management lifecycle, data management lifecycle. But what we see, and not just in this instance, but in most subject disciplines, is they're missing two key components. And one is that data management plan concept and the archive and preserve concept. And so what we're advocating in the field of journalism, and actually since we're librarians and we work in a lot of different areas, in any field we're advocating for this, that you consider implementing a data management plan that will better aid in documenting the data that you're collecting and putting out there for people to use. And I'll leave it at that. Has anyone ever heard of or used a data management plan? Awesome, great. Okay, for those of you who are like, no, what the heck is that? So just briefly, some of you may or may not be aware of, several years ago, actually, the federal government started mandating that anyone who was receiving grant funding from a federal agency create a data management plan. So it documents what kind of data you're going to be using and emphasizes where you're going to place that data and make it available, because we're giving you money to fund your research. We want to make sure that the public has access to this. In California, they actually recently just passed a bill, so anyone receiving state agency funding is now being mandated to do this type of data sharing. So this actually comes from, federal regulations and laws that mandate it. And what we've done in libraries is we've tried to implement this not just for those people who are getting federal grant money, but it's just a good set of best practices for this.
Okay, so you might be asking what's the difference between archiving and preservation, and there is a difference. archiving could just be putting your scripts in GitHub, but that doesn't guarantee that they will remain there or that they'll be preserved for the long tail. So preservation is really a commitment to backing up your data and provisioning for file versions, as well as migration to future formats, and maybe having emulation software to be able to recreate your project using the data that you deposit. So what we have here are some additional reasons for for doing this. So for verification, replication, fact-checking, etc. Then we have some suggested archival formats for your data at this point in time. And then if you'll notice this resource list and demo materials that we put together at this Pearl, you can see some suggested data formats, repositories that are available to you and sometimes not, and then just some of the articles that and some data management plans. So I just want to also point out that when you're archiving your data, you also want to consider saving your data in a non-proprietary format, because that can cause all kinds of problems in the future if it's in proprietary formats. Using standard character encodings and uncompressed if space allows, and open with documented standards. So what are the data that we're talking about? So we have, listed here some structured and unstructured types, but what we want to emphasize too is that we're looking for not just the raw data, but the software and the version info that goes with it, or information about the software that you used for your project, the algorithms, for sure, files that you use to analyze the data, metadata, so data about your data, code books if necessary, and just more description about what your variables are, and clear license statements about how others might be able to use your data in the future, and a detailed README file. We have some data sets in our repository that we looked at and we were like, is someone going to be able to use this in the future? And sometimes you're not going to be depositing the actual data because it's proprietary or it's available, at a government website, like census data, for example. But if you can archive the details about your project and what you used, that's really useful to others.
So again, we get a lot of questions of, wow, that's an awful lot of work. I mean, you want me to write up all the, my code book, you want me to, document all this. I just got to get this research done. I got the data, and I got to, move on, because guess what? I have my next news story coming up, or I've got another class, or, this is only one little part of my overall, research that I'm doing. We get that and understand that. So what I typically say as a rule of thumb is, think of it in this context. If you were not available, you put your information, you put all your data up, if you weren't available for someone to come and contact you directly, are you leaving enough of a roadmap for them to be able to utilize your data? It's just a question. That's a very simple question. It's a very, you can use it in whenever you're doing your research, whenever you're putting all your information together and documenting it. There's actually also tools out there to help facilitate metadata creation. There's things like the DDI, the Data Documentation Initiative, who have been working to create automated tools that can scrape the metadata out of, if you've got an Excel spreadsheet. So there are actually ways that you can do this quickly. We demoed last night one of our instances of a form that we've used to help researchers create that kind of metadata quickly, and also give you ideas of what you should be documenting, because we've found that a lot of people are like, well, what do I need to document? Do I need to document the units of analysis, my sample size, the levels of geography? And those are all very important. And I guess, again, it's going to be dependent upon kind of what your research is and what is needed to be able to give somebody that roadmap to recreate it. So again, you want to make sure you've got all the pieces of the puzzle so somebody can put that puzzle back together if they want, or if they want to create their own puzzle. And lastly, just to drive that home, I was curious about GitHub because I know this is the latest and greatest place where people are parking all of their code and information. Fabulous. It's a great access point. It's well known. But in their own documentation, they do not provide archiving. So they're not doing that level, that committed level of archiving and long-term preservation. So you might want to think about, you might have some access, have uses for access, but in the long term, if you want people to be getting back to this information, you all are doing really important and great research, think about putting it in an institutional repository. And as Regina mentioned, sometimes there are reasons why you can't actually share the data that you get. Tom McGinty was an awesome example yesterday with his Medicare data. When he was talking about that, I was like, oh my goodness, is that available? Because I already know a bunch of researchers who would love to delve into this. And no, guess what? It's not. As he said, it wasn't. However, when you're dealing with that type of restricted data, and we've actually acquired data at Stanford for researchers that restricts it only to the Stanford campus. They can only share what we, in legal terms, call a de minimis amount, and that's never really clearly defined. It's kind of murky. But what they can share, what we've made sure we clarified when we were getting that data, is what are we able to share? Is specifically, we can share the variables, the code book, so they can talk about the data, they can cite the company that we got it from. So these are all things that you can do, even if you're dealing with restricted or proprietary fee-for-access data. I mean, there's data out there, you have to pay for to get it. You may not be able to share it. So again, being able to clearly document and leave that roadmap is important. And then we also talk about, so that's getting the data, but on the tail end of it is sharing the data. So we recommend using something like Creative Commons. Have people heard of Creative Commons? Okay, I recommend for those who haven't, you start considering using this even in your presentations. When you give a presentation, tell people what they can do with that, because you may want to come back and grab one of our slides and utilize it in a classroom setting, in one of your presentations. So you want to tell people what can they do with that data. Can they not use it at all? Do they have to cite you and give attribution? Can it be used for commercial use, or if you don't want it to be used for commercial use? And off to the side, you see the PDDL and ODC. There's actually, let me get this right. It is the Open Knowledge Foundation. I know it is OKF, Open Data Licenses. So even now in this day and age, they've actually moved beyond just Creative Commons to having data licensing, standard data licensing for data sets. So that brings us to one of our first case studies. So we wanted to give you kind of a glimpse of some of these practices actually in practice. As I mentioned, I'm a government information librarian. I work with students, but I also work with government agencies. And everyone's heard the whole open data movement, especially at the state and the local levels. And what I've been able to do is do some outreach with the County of San Mateo. And I actually work with a lot of cities in Southern California as well. And the one thing that I always found very troubling when they start putting their data up in, say, their open data portals here, is that they, one, haven't clarified that copyright issue because as much as we don't want to think about it, state and local government information actually is copyrighted unless they actually say it's in the public domain. And then what is their strategy for long-term access and archiving? Right now, I work with students and researchers and even just general citizens who come in and they want, 20 years of voter registration data. They want to look at parcel data, not just for the most recent from the county assessor's office, but they want to go back 10 or 50 years. So what are they doing? What is their strategy? And typically they're like, well, just come in and ask us, and we'll hopefully be able to spin it off that disk that we've got. So what we're attempting to do with San Mateo is to do a pilot and say, okay, so you're putting data sets up they're using Socrata. Socrata and MarkLogic are the two big kind of corporate entities that are doing this service. We're taking out their CSV file and their PDF files, and we're archiving it in the Stanford Digital Repository. It's a test. We'll see if we can actually scale that out. We might come up with some better solutions for that. But that's a way for me to be proactively collecting this information for our users down the road.
Yeah, and one of the reasons why we're doing that is because sometimes when in Socrata they might refresh the data, and so what was there yesterday has been changed. So that's one of the reasons why Chris is doing that. So my case study is more a little bit of a tangent into text and data mining, and so if we think about text and data mining as a new way of reading, there are a lot of issues with licensing when we want to use a corpora of text that's still in copyright. And so I'm working with some researchers, and we're trying to figure out a way to get them a corpora of text that's current and up to date and still in copyright. And this particular vendor of information of articles in a proprietary database is not willing to send us the corpora files that would be required to do the text analysis. And so we're currently negotiating. It's not quite there yet, but close. Hopefully I'll have some good news soon. But what we've suggested is that because they won't let the data leave their servers, that they create a secure virtual space for our researchers to log into and run their experiments, and then extract their TDM output, and then use that for their projects. And so what we're hoping is that will work out, but also I just want to say that with TDM output, we should definitely remind ourselves that is not under copyright. Once it's created, it's fair use, and it's new data. So the workaround of the secure virtual server space, there is an example of that at ICPSR, and so that's listed on here. And that's what we've suggested that this vendor create for us, and so we're working very closely with them to try to make that happen. But it's a challenge for sure, getting aggregators of published data or published articles to comply. A lot of aggregators are allowing API use of metadata, and so sometimes that is a possibility, but it's usually for old texts that are out of copyright. Or sometimes they'll send a CD, and then you have to take the steps to erase all that content once you're finished and prove that you've done so. So those are some of the things that people are doing. Just a final point on that is just that you can use your librarians and libraries to try to help negotiate these licenses, because they already have some license agreements in place. And so if you are at an institution, that you should go speak to your data librarian or data archivist or subject specialist librarian and see if they can help you find the most appropriate source, because it's kind of a shame, I think, to have to settle for using some other corpora of text when the most appropriate corpora might actually be something that's proprietary. I mean, I know there's a lot out there that's open, and that some people are scraping, and that's a little bit illegal. So, you know, it just depends. And then, so like in this case, we're trying to, you know, do it ethically. Okay. So some final recommendations is to think through your data management plan from the beginning. And we were talking with people yesterday, like, wouldn't it be great to have, if you had, you know, a data management plan where you filled in a lot of your information, and by the end of your project, you just had a script that sucked it into the forms that we have for the archiving. So anyone who wants to work with us on that, let us know. And then, yeah, document your methods along the way, document the software that you use and the algorithms and scripts, and archive those as well. Seek secure data storage, and there's options even if your institution doesn't have an institutional repository. There's ICPSR, and Dataverse looks open. And so work with your librarians, deposit your data and metadata, and then make your license clearly understandable for other people so that they know how that they may be able to reuse your data or test your project.
So just a final closing thought. We really thank one of our reviewers who gave us a lot to think about and chew on with our paper. And one thing that they had noted was this Panda project that was a Knight Foundation grant-funded project. And it's a way for newsrooms to actually have a place for you to park your data. So we went and tinkered around with it, and we noticed that it was missing a lot of the kind of best practices that we were talking about today. So we thought we would leave you with kind of this lovely hand drawing of a Panda 2.0, how we would envision that. And so you would see we've got all the data. We've got kind of a sample of what we're talking about in terms of documenting the data. It can go into an access repository of what you can actually install this client on your computer. But then think about pairing up with an institutional repository. And I've just listed a couple possibilities there. And I believe they were located out, it was IRE, which is at the University of Missouri, and they do have their own institutional repository, MoSpace. So that's a great opportunity for those two kind of worlds to come together and collaborate, see if they can make something happen for this. So thank you. And we want to put in our best practices into practice for you all this morning. So there you go.
Time for a couple questions.
Hi, I'm in the scientific communities thinking about reproducibility in science and building tools that encourage reproducibility. And one thing that we've found is that unless the tools that the scientists are using every day for their work have reproducibility sort of embedded in the middle of them, it will not happen. Like, no amount of sticks will get scientists to do it unless the tools just do it automatically. Any thoughts on how to address that sort of
So actually,
aspect?
yeah, so this gives me a good opportunity to thank Professor Christine Borgman, who teaches out at UCLA. I was one of the practitioners in her data curation class, and she's heavily science-based. I was more of the social sciences, humanities side in the class, and so I can't tell you how many weeks and months we spent discussing this, because we know in the scientific data, they're working with embedded network sensor system, and so the SENS project out there, and that's the problem, right? I mean, any of those sensors, something gets calibrated wonky, they change, there's so much variability and flexibility. So that's why we spent a lot of time saying, well, what are the data? How do you document it, especially when it's really hard to nail it down in the sciences? So what level of information has to be there? Sometimes it is just the documenting. You can't actually include the sensors that you used as part of your data set. Sometimes they're still out in the field or they've broken, or tissue samples. Sometimes you can't necessarily, unless you have a tissue bank, that you can do that. So that is tricky, which is where that documentation side comes in. And just being overt and saying, hey, these were the issues, the factors that we ran into. It rained and it shorted out this particular sensor, and we ran into issues, or we were using a variety of sensors from a variety of different manufacturers, just to kind of let people open up that process and make it more transparent. because chances are in the science field, everyone's running into those, and scientists that we have talked to and seen this, there is that understanding that happens. That's just the way of the world. So how do you document that?
Well, I have a comment. I have a comment on that too as well. I mean, it's important to archive your data, not just so other people can replicate it, but also it's part of tenure. And so that would hopefully inspire some to do the work. But also, I mean, we were discussing yesterday that maybe there could be some new tools created to help make that process more automated, and then just having going through the data management process in the beginning of your research too helps you to just keep track of where things are going so by the end it's just easier to upload to a repository. And also just with the granting institutions too, they require it. So, I think more and more institutions and organizations have to recognize that and make the institutional repositories accessible for their researchers. It's the changing nature of research. Just as I was discussing copyright issues, it hasn't caught up to the digital, era.
Hi. I was wondering whether you ever encountered situations where people might be deleting data and you might be required to remove data from the archive. So recently we started encountering this problem because we were doing some research on Twitter data sets. And the problem is people keep deleting some of their data, sometimes long in the past, 5-6 years, that they posted 5-6 years ago. And the Twitter Terms of Service says they would recommend that the data not be analyzed any further. But what this creates a huge problem for us because every month there is some tweets in the data set that we have analyzed before that is changing. And so we're wondering, like, what should we be distributing to other researchers? Should we keep changing the archive?
Right. Yeah. Do you want to?
Well, I'm just going to start, but Chris has worked with Twitter data before, so I'll let her finish. But it's important to also, before you deposit your data, make sure that you have permissions or that the data's been cleaned of personal identification information and that sort of thing.
So not only the Twitter data that I've worked with, but I work with international data. So IMF, if anyone has worked with their big 4 data sets, the balance of payments, their IFS, all of those, and we've talked to the economists there, they want to make sure that the data that's out there is correct and accurate. Well, unfortunately, we have researchers who've worked with those data sets 5 years ago, 10 years ago, and then the data got refreshed and corrected down the road. And so what they've cited in their paper, if someone was to go back to it, there may be some discrepancies in that data. So it's a real live situation, and there are different approaches to dealing with it. For the IMF data situation, we still get the print to have a hard copy of what those numbers were, and we subscribe to that CD-ROM that had it, so we still have that data from those time periods. So in a way, and then we've got the current online. And we also explain to people that's the situation, document it. You got to document, that comes with so the documenting can actually help, even though this is a quandary that you're dealing with, and it's not, but a great solution, at least if you're documenting what's happening. The other thing is in the institutional repository, are you getting a live feed from Twitter, or have you captured it and you've brought it in and then you're working with that captured set? Yeah, I have an entire paper I can give you on that because we talked about privacy and Twitter data, which everyone looked at us and they're like, it's public. They know, but there are inherent issues with that. I mean, it doesn't seem like good data stewardship to have people go in and delete their data from those data sets. I mean, if you've acquired that data, you've put it up, that's there. With that said, there are issues at times where errors, there's the great example of the Harvard Facebook study where they published that data set in the honor of sharing their data, but it was easily identified pretty quickly, and then they had to take that data down. Yeah, that's a whole other, there's actually, I think it's the Association of Internet Researchers have written a lot about this. Dana Boyd as well has written a lot about this. So that would be a talk for probably another day to go into it.
All right, let's thank the speakers. Thanks.
Thank you.
Next up, we have Thomas Petracek. I hope I didn't butcher that too badly. He'll be speaking to us about the Gamma, programming tools for transparent data journalism.
Well, no. I'll get to here. All right. Can everyone hear me well if I'm just standing here? All right, thanks. So my background is more on the computation side, and I recently submitted my PhD thesis at the University of Cambridge, working on programming languages stuff. And I guess as every PhD student, when you're writing up your thesis, you spend a lot of time reading random stuff on the internet and not doing the actual work. So that was definitely my case. And one of the things I sort of discovered is that there's actually a lot of interesting things happening in the media where people are increasingly using data. And so that's how I got interested in the space. And I just picked one example here, which is an article that says China overtakes US as the world's largest carbon emission producer. This article actually was published in, I think, 2007, probably before charts were invented, because it has no charts in it. But there's a more recent article from The Economist, which discusses pretty much the same topic, and it compares carbon emissions from the US and the China. So they have this pretty chart there in the article, and as a computer scientist, whenever I see this sort of chart, I'm always wondering, how did they do it? What data source are they using? All right, well, they're telling me that in a comment, but how did they transform the data? Or can I actually add another country to the comparison? I'm curious about India because that's the third one. So that's what I always felt that it's something that should be there whenever I'm reading a newspaper article online. And I think there's really important topics from the sort of correctness side as well. So the first thing is, can we actually reproduce it? Like, is the data used correctly? And I would probably trust The Economist. I was told that a safe joke to make is that maybe I shouldn't trust Fox News. But there was this recent famous paper in economics where they were analyzing data on growth based on debt in countries, and they actually did some manual processing, the kind of thing that many people would do, where you get some data, paste it in a spreadsheet, copy it, do some analysis, and they accidentally dropped some of the columns from the data in the manual process. And that sort of invalidated the whole point of the article. So one thing is, can we actually reproduce it, and do we get the same results, and sort of independently verify it? The other bit is the article actually sort of, is it showing just the data they want to show you to lead you to some belief? With the China, they are the largest carbon emissions producer if you look at the total amount in kilotons, but you can see a different number if you look at the values as relative per person, so per capita. And that's some of the things that I really want to explore as a, say, more advanced reader. And it's basically the inspiration behind the project that I want to show here. So I'll start with just a really simple example, and this is, I'll give you a link to everything later on, but this is a similar example that compares carbon emissions for different countries across the world, and this is showing you the total number. And it looks pretty much like a normal article. The main difference is that there's source code behind everything that's happening here. So you can do things like draw some maps, put in a table, or there's, I've heard in the morning pie charts are almost always wrong, but I do have a pie chart. So this is showing you the top 6 countries and the remaining countries in the total carbon emissions. So you can see the first 3 take roughly half. So that's the sort of front side of the project, but it's not just text and images, as you get more usually, because there's more behind it, and we can actually rerun the whole thing and reproduce everything. It's open in the sense that there is a source code that you can look at, you can understand how it's done, and you can also, the example was using the World Bank as the data source, and they have a nice API you can call, so you can exactly trace what data source it's using. And the sort of theme behind this is that you can really look at the article not just as a text and pictures, but more as a program. So it's shifting the format of articles from text to something that's more like a program. And I'll show you the source code for everything later on as well, but it actually is just a markdown document with some code that you can find on GitHub. The really interesting thing is that when we treat the article in this way, we can do a lot of things on top of it. So when I came to the website, the example I was showing before, you would just see the journalist story. So you see what the article author wrote, how they are using the data to support their story, and I think that's what most of the readers really just want to consume. But the really interesting bit is that you can modify some of the parameters. So if I go back, there's this options button, and oh yeah, you have a good projector, so you can even see the gray options button. But this gives me access, this gives me some options for picking different things from the data source. And so what I can do here is to actually choose another indicator. And the way this works is that these indicators are live generated from the indicators that the World Bank has. So it's connected live to the data source. If they added a new indicator tomorrow, it would actually appear there. And you also see the metadata on the side. So this is everything that World Bank gives me about the data. So let's look at metric tons per capita. And this is where you can start exploring different perspectives. If you look at the per capita numbers, then suddenly China isn't that bad in this perspective. So you get more of that. The other thing that it actually lets you do, and I didn't want to scare people by starting from the source code, but you can have a look at the source code and see how exactly it's done. So that's another thing that you can do here. And if I click on the source, then you can see the full source code. The hardest part was choosing the right colors, so that's the first 3 lines. But then the rest is accessing data from the World Bank and sending it to the chart. Now, there's more interesting technology behind it, and when I was working on this, I definitely didn't want to just make journalists write code. I think there was a lot of talk in the talks in the morning about how journalists need to understand more of a programming, But I think equally, there's a lot more that the programming language people could do to actually make this stuff much easier. And one of the things that's really a lot easier here is when I'm accessing the data, this is using a library. Let's see, what did I do? I apparently did something wrong here. I do have another version loaded right here. So this is using a library that links the program to the data source. So rather than directly calling the World Bank using some JSON-based API, I actually have that data directly available here. And again, you can see on the side some metadata about the data source. And when I do world dot, this just gives me two different perspectives, two different ways of accessing the data. So here I can pick a year and then get data for all the countries, or I can pick a country and then get data for multiple years. And when I'm exploring the data, this is again live and connected to the World Bank. So they have data for these different years, and I can pick, let's do 1990, and then I'll see all the indicators. So here I was looking at the climate change category, and under that you can explore again all the indicators. So the same thing that I was showing before in the UI, in the dropdown, what readers might explore, you actually have that exactly the same thing when you're writing this or when you're modifying this. So let me go back to carbon emissions. Now if we change it, then this is showing the data for 1990s, where the World Bank didn't have data for the former Eastern Bloc, and US was producing more carbon than China. So the technology behind it, there's two interesting things that have been done in programming languages world that I think would be really useful for journalism. One is the idea of type providers. So that's the tool that integrates the external data source into the language. When I do World Bank dot and I see all that's available there. The other thing is we can actually, and this is something you get in many programming languages, we can actually give people a lot of really good editor tooling. So when you're writing code in something like Java, there's a lot of tools that are helping you. And we can take this and make it available in the data journalism context so that even if you don't have strong computer science background, you can just have a look at one of these examples here. I'll actually scroll down to another one because this one is interesting as well. This is comparing some of the largest producers over several years. And if I look at the source code, this starts by building some sort of list of countries that I want to compare, and then it does some calculation to get all the data. But again, I have this editor here that lets me add or remove countries, and whenever I do a change in the editor, it actually will be reflected in the code. So you can have a look at this, see how it works, and as you're using this, you can actually understand how the code is created, even if you're not sort of starting by working on the code. All right, so that's the tooling side of this. And there's a couple of interesting problems. One is, how do we integrate all the different useful data sources into this? So the World Bank is a pretty nice example because they actually have just sort of three-dimensional data structure, and we can slice it in different ways. So the example I was using before is that we first choose a year, and then based on the year, or we pick a specific year, then we pick a specific indicator, and what we get back is a series with data for all the different countries. We have one data point. and then I can show that in a chart with a map, or you could slice it differently and get data for all the years. Or you could actually slice it down to a single individual value if you were just displaying one value. And the type provider here, the integration, maps this really sort of nice data source from the World Bank into the programming environment so that you can just browse through it and navigate to the point that you're interested in. And I think the really important bit here is that whenever I have the source code behind it, so whenever I have something like this, we can also do a fairly standard thing in the programming languages space, which is we can trace how the data is propagated through the program. And so here, this is one thing that this prototype isn't actually doing, but could be doing quite easily, is that we can trace how the data goes through the whole computation. And at the end, when I'm showing the chart, I know the data source for everything that's used in the computation. And that's one of the things that I get just by having the full reproducible source code or the instructions behind it. And that's pretty much what I think you lose whenever you involve some manual steps. Like when you download the data from somewhere, copy it somewhere, that's where you're losing this link. So the project is kind of trying to keep the full link and give you as many benefits as you can get from having that direct connection here. There's a bunch of things that I guess once you treat the program, once you treat the article as some sort of program with a full source code, there's a bunch of interesting things you can do around it. And so some of the things I mentioned already is we could actually trace the data sources. There's, I guess the interesting question here is how can we actually integrate other interesting data sources like the various open government data initiatives. So that's a big interesting question here. You can also, if you're displaying a number in the article that's computed from one of the data sources, you could do the kind of thing that Jake Hoffman was showing here yesterday, which is show it in a context, because you know how it was created and you know what the context actually is. And you can also, so this is another example that's showing the same kind of technique, but here I'm using the nice link to the data source only as a source for some script that I'm calling. And this is, again, something I chatted with Jay Hoffman about yesterday, and I put together a quick sample where if you pick a US state, it will find the most similar countries in the world based on the population and the area. So it often turns out to be interesting. If you choose New York, then it's Syria. I think if you choose one other state I randomly tried yesterday was very similar to Iraq. But this is, again, sort of just using that idea that you can link to the data source, and then in the first examples I was showing, I just plugged it into some map. Here I plugged it into some more interactive application that was actually written using a bunch of JavaScript. And I think in summary, so this is a project that I built, and I'm coming from the computer science background, and I would really like to work with some people who are interested in using it. So if you're working in a media and you're using some charts based on some data sources, then you can find me later on. I would really like to talk with people and see how we can make it really usable. And this is sort of interesting research question for the programming language world as well. How do we actually make the programming environment easy enough that it can be used? And in summary, I think the sort of key idea here is that this is something that's trying to encourage more active information literacy. So rather than people just looking at the charts, we want to give them more power to actually explore it a bit more. and maybe learn something on the side as well. And the idea that we could treat the article more as a program than just as text and pictures, I think that gives us a lot of power to do lots of interesting things on top of it, like analyze the data sources, give people automatically options to change it, and so on. And I think there's a big quest for the programming language community as well, because whenever someone said lots of ugly JavaScript here, I was like, we can fix this. So thanks for listening, and hopefully I'll talk to some more people later on.
All right, we have time for a few questions.
Hi, so I'm a statistical and data sciences professor at Smith College, and I'm just wondering if you can talk about how the Gamma project compares to like the IPython notebook, Project Jupyter, R Markdown, those sorts of text code reproducible things.
Yeah. So how does this compare to things like IPython notebook? So I think it's really following the sort of very similar idea. The main difference here is this like link to the data sources, which you can do in, say, IPython notebook if you're calling the API directly. This is trying to make it sort of as simple as possible and remove all the noise that you don't really need to have there. So it's sort of coming from the same perspective. I guess all the tools like IPython notebook, the R and Markdown integration, they're really aimed more at data scientists who have some computer science background. And what we are trying to do here is to make something that journalists could use with just sort of maybe do the 90% of the things that you might want to do, but do it as simple as possible. Thanks.
Hey, so isn't this project, I guess, at odds with the whole archiving idea? Because if I don't quite understand the caching layer, but if World Bank decided to stop publishing, would the data not live on anymore in the article?
Yeah. So that's a really good question, and I think so the current prototype doesn't really do too much of clever caching. There's definitely more that could be done on that side. So whenever you see a final report that you want to archive, you can definitely ask it to cache all the data that it was using in the process to make it archivable. But I think there's probably two angles to look at it, because on one side you want to have just a snapshot of what's happened, and on the other side you also want to be able to come back to an article that was published 5 years ago and see how the situation has changed, assuming the live data source is still live. So there's definitely some archiving that probably should be done there. And if you publish a version of the article on your newspaper website, you don't want it to stop working when World Bank suddenly changes their API.
I like that there's some tension here. It makes me feel like there's still work to be done in this field.
Is your intended user the journalists or the readers?
So I think I'm sort of hoping that both could use parts of it. And there's sort of, the reader, I expect, would be the kind of person who comes to it, looks at the charts, and maybe fiddles with the options. The journalist, I expect, would be someone who would want to easily create the visualizations based on the data, embed it into their articles. So there's something for both of the groups. And I'm kind of thinking that every now and then there might be some reader who actually has some programming background and will be willing to fiddle with it a bit more. There's probably more that could be done in terms of letting the readers add their own perspectives to it and just have a forked version of the article that's actually in place of instead of putting a comment on it, they could have more data backing their point.
Tomas, this is very nice. A couple of things. So how about scalability, and also then kind of thinking about the fact that there might be two different data sources that you may want to link to, not just one, to kind of expound on the whole topic.
Yeah.
And how much effort it takes on your part to create a system that would actually result in either a reader or a journalist producing this.
Yeah, so on the scalability side, I think the bit that I haven't really solved here is the like how do you add support for another data source? That is something that can be done, but you need to know a bit more about programming to actually do it. Like it's harder than just calling an API when you're accessing one specific data source. I'm pretty sure that's something that can be solved just by having a nicer library or using some standardized formats like linked data and so on. But that's definitely an interesting problem. On the side of creating one of these things, I think that should be pretty easy because if we had, like the example I was showing had some like 3 different charts, and modifying them, like taking one of these and just changing the parameters can get you pretty far in terms of the different visualizations you can do based on that one data source. Now, the second part of the question, what if we had multiple different data sources that give me access to the same data? Then I guess that's one part where we could initially just let the people who know more about programming play with it and do things like actually get the data from both of the different data sources, match them, and calculate the differences and so on. That's where I kind of think that having the program behind it is actually really valuable, even if most people will not need it, because that's what lets you do the additional things that are really impossible to do in environments where you don't have the full code behind it.
Let's thank our speaker again. Thank you.
Thank you.
And next up, we have the quest to automate fact-checking. Bill Adair will be speaking.
We need audio. Great. All right. I am Bill Adair. I'm the Knight Chair at Duke. I'm also the creator of the fact-checking website PolitiFact, which is how I'm involved in this. I still work as a contributing editor at PolitiFact. And this is part of a project that's been going on for a couple of years with some computer scientists at Duke, with some computer scientists at the University of Texas at Arlington, including Nafi. You want to introduce yourself?
Hi, this is Naimul Hassan. I'm from UT Arlington. I'm a PhD student under Dr. Shankali. I'm mostly working on fact-checking and fact-finding.
And 2 of our other co-authors are here, Jay Hamilton from Stanford and Kong Yu from Google. So we're just going to talk a little bit about one piece of our project today and offer what we're calling a call to arms to try to get your help and the help of other researchers in
trying to automate fact-checking. And I come to this obviously from a personal standpoint as a journalist, as a fact-checker. Started PolitiFact in 2007 and have over the years realized the value of computational power in helping journalists do this in two ways, and we're going to talk about both ways today. One is how computational power can help the journalists who are doing the analysis, finding facts to check, actually starting with finding facts to check, doing the analysis. And then the second piece, which I'm going to show you, we call the Holy Grail, is how we can automate the matching of fact-checking with political claims that are made so that it's instant. So let me just start with a little quick overview here. So there are currently about 64 active fact-checking sites around the world. I oversee the Duke Reporters Lab where we keep tabs on that. That's up from 44 last year. We've had new sites in some unlikely places: Russia, Canada, Nepal, and Northern Ireland. There's a new site just getting started in Northern Ireland. Falsehoods, of course, grow faster than fact checkers. That's the big challenge. But I'm pretty encouraged by this movement. I think as it continues to grow, we're really helping people make sense of the political discourse. It's important to understand this is a very labor-intensive form of journalism. It's not like everybody are like, can you do live fact-checking of a debate? And the reality is that fact-checking takes time. It involves research, it involves analysis. You have to do some pretty traditional journalism that can be time-consuming, so a typical fact-check takes about 1 day. Just to give you an idea, this is from our Duke database of the fact-checking sites. Each check there is a fact-checking site in the US and Mexico, and here's what it looks like in Europe and a little bit of Asia. Tremendous growth, particularly in Europe and in Eastern Europe. So what are the opportunities? So the opportunities are we can create some tools and apps that assist journalists in doing fact-checking, and we're going to show you a demo of ClaimBuster. Can also analyze claims, which is some work we've been doing at Duke that we call iCheck. And the other way is to create tools and apps that assist consumers. And this is where we think there's great potential to create browser extensions that match claims and fact checks. There's been some work in this done by Dan Schultz, who was a student at the MIT Media Lab, a project he called Truth Goggles, and there's some other kind of similar things like that in annotating content on the web. And what we call the Holy Grail, which is instant matching of claims and fact checks. So think of it as an opportunity when a political claim is made that you can instantly know whether it's true or false. So that claim might be made in a campaign ad, it might be made in a speech, but using technology, wouldn't it be tremendous if the minute that the claim is made, we could provide the additional information about whether the statement was accurate? So that's my rendition of the Holy Grail, the Truthometer, obviously from PolitiFact. So how would this work? So you're watching a soccer match, and a campaign ad comes on, and you're running an app on your TV, and the app instantly detects that that's a campaign ad and knows that it's been fact-checked, and it pops up some information about whether the statement is accurate. And depending on your television, assuming it's an internet-enabled television that would allow this kind of additional information, you could even pause the action and go to the fact check. But at least you would have the additional information. To us, this is the Holy Grail. Now, this is where we would love, we had some interesting discussions yesterday where we were just kind of brainstorming, how could you do this? Of course, technologically it's very challenging because even in the so-called smart TVs, it's really two ecosystems. You have a cable line, a traditional coaxial cable coming in that's providing the television signal, and then you have the internet side that would provide the apps. And from the preliminary research that I've done, it's difficult for those two ecosystems to communicate with each other, or maybe impossible, that the app is running independently of the cable TV signal. But I expect if we get enough smart people looking into this, we can solve it. So let's talk about the technical hurdles. So now let's step back to the fact checks. Most fact checks around the world on those 64 sites are published kind of the old way. If we think of the internet age, that there is an old way. They're published in old blog formats, such as WordPress, and that means they are not structured journalism. So structured journalism is my other focus in the Duke Reporters Lab, and the way that most fact checks are formatted is with essentially two fields of data, headline and text. And so they are not segmented so that you have a statement, a speaker, a rating, and so that makes it harder to do this kind of matching, although not impossible. Current publishers have inconsistent coding, if any, for video and campaign ads. So in the PolitiFact database, for example, if we have a related YouTube video, we will put a code in our database, but many other fact checkers don't have that kind of structure that PolitiFact has. They will embed it, but there's no consistent way that that's done. And then, of course, you have the challenge of just natural language, of different ways that claims are said, and the challenge of matching. If you were to have some sort of a detection, as you'll see with ClaimBuster, where you determine the factual claim, you need to match that against your database of other factual claims, and the statement that has been fact-checked may not exactly match the statement the way it's uttered now. Here's an example that we had at PolitiFact. Barack Obama said preventive health care saves money, and we had already done a fact check, but we had done it on a different way of making that statement, a statement by a columnist at the New York Times who said, does preventive care save money? No. So you see just in those two statements, the natural language challenges. So those are the challenges, but help us. So what are our next steps? We'd like to develop apps that detect political messages in video and audio. Our first thought is to build a browser extension for Chrome that would detect a YouTube ad that had been fact-checked, and this is part of something that we're proposing in the Night News Challenge. You could build a cable broadcast TV app for a smart TV. We think that's difficult. You could build, now that Apple has opened up the Apple TV to developers, we think there's a possibility there, but they're too difficult. And we're building ClaimBuster, and now Nafi's going to talk a little bit about that and do a little demo. So it's on Chrome.
Hi. As Bill said, we need to check the facts, but before we check the facts, we need to understand what are the facts that we need to check. So we built a tool, ClaimBuster, that can help to find the check-worthy factual claims from political discourses. So let me explain the approach we took, and let's see how we model the problem. So here is the overview. We have the presidential debate transcript of last 30 years, and we collected the ground truth by using a human annotation, and then we extracted some features from this data, and then we applied some learning algorithms and saw how we can have a classification model or a learning model that can help us detecting the check-worthy factual claims. So this is the overview. In the coming slides, I'll try to explain each of the concepts. So here is the overview of the presidential debate transcripts. As I said, in last 30, from 1960 to 2012, there are 30 debates, And in all these debates, we have about 20,000 sentences, which are small. By small, I mean having smaller than, less than 5 words. So in the below 2 graphs, you can have a look at the distribution of number of sentences in each debate. On the right graph, you can see how long the sentences are in each debate. So an observation can be in recent debates, the speakers use smaller sentences. And in earlier debates, the speakers actually use longer sentences. That's about the style. And on the left side, you can see a graph of number of sentences in each debate. So obviously, in earlier debates, there are small number of sentences, less number of sentences, but now we have more sentences. It can be possible because of the format of the debate or the style of the speaker, as I said earlier. Okay, so once we have the transcript, we saw that there are 3 kinds of, or at least we can categorize the sentences in 3 types of categories. The first one is the important factual claims. For example, we spend less on the military today than at any time in our history. And another example can be more people are unemployed today than 4 years ago. So these are the examples of check-worthy factual claims which the journalists take from the transcript and further check whether they are true or not. Other type of sentences are unimportant factual claim. For example, I was in Iowa yesterday. My mother enjoys cooking. So these are definitely factual statements, but probably not worth checking, and probably general public will not be interested in knowing whether this is true or false. And the third category is a sentence which doesn't have anything to do with factual claim. It's just an opinion or declarations or questions. For example, Iran must not get nuclear weapons. Our plan is to reduce tax rate by 10%. So having these categories, here is our goal. Given a new sentence, find the class it belongs to, whether it's NFS, I mean the non-factual claim, or CFS, the first one, important factual claim. And we can actually model this as a supervised learning problem. All right, so to get the ground truth, we actually build a data collection platform. There's a website, bit.ly.claimbusters. And in 3 months, we successfully accumulated almost 200 participants. These has students, professors, and journalists. And we used some screening questions. Here we mentioned 600, but so far we have already 1,000 of them. So these screening questions are there to monitor the spamming activity or to control the low quality participants. And we only select the sentences for which we have high quality response from 2 coders. So that's our ground truth. So as I said, we had actually 20,000 sentences, and after all this controlling mechanism, we come down to 8,000 sentences so far. So for these 8,000 sentences, we have high quality label, at least 2 of them. Now, what is the distribution of these sentences? The distribution looks like the table here. So many of these sentences are non-factual. Almost 6,000 of them are non-factual. There are 1,600 check-worthy factual statements, which is CFS, and only about 500 of them are factual claim, but not so important. So here's a screenshot of our data collection system. All right, so once we have the ground truth, the next step is to find the features from the data. So we used text-to-speech, entities, concepts, and keywords, bag of words model to get the features from a sentence. And the next step is, once we have the features, can we actually find the best features or the most discriminating features? So we did some analysis, and we found that number plays a very important role in discriminating whether it's a factual statement, check-worthy factual statement or not. The other important features are concepts like United States, Barack Obama, and some personal speech like noun. All right. So using these features, we tried different classification algorithm, naive Bayes, SVM. Generally, SVM did a pretty good job. And we had about 75% recall and 79% precision in detecting the checkered defactual claims. So we have a model, we have some good results, but how does it perform in real world, in real data? So we actually got a chance to experiment on a real event. We applied our model on the first Republican debate that was in August 6th. We got the transcript, live transcript from using text grabber. We actually collected the closed caption. And we passed this data to our model. And we ranked the sentences by how checkworthy they are. And we found that in the top 250 sentences, we have covered about 70% of the claims which were checked by CNN, PolitiFact, and factcheck.org. So this is pretty amazing. Now, let me show you the demonstration, the demo we have. This is the URL. If you'd like to take a picture, irrutl.edu/claimbuster. So let me give you a short demo. So this is how our demo looks like. We have covered the 2 Republican debates so far. Let me show the second one, the latest one. Here you can see the transcript of the debate and the video of the debate here. If we start playing the video,
I'm Jay Tapper. We're live at the Ronald Reagan Library in Simi Valley, California.
An agreement.
So you can see when the debate is going on, we have the transcript, and our model is live giving the score of each sentences, how checkworthy that is.
Make sure that they
if
have
the score is close to 1 or the color is darker, it means the sentence is more checkworthy. If the color is lighter, it means it's less checkworthy. So here you can look at the transcript and the numbers here. We can rank the sentences by the score. It will allow us to see what are the top checkworthy sentences in that debate. So one interesting example can be we balanced 3.6 billion budget deficit. We did it by cutting taxes, 4.7 billion to help working families, family farmers, and etc. So these are the things that journalists may go ahead and check, and it may help them to kind of reduce their time.
The entire Middle East, but
we have some
the United States of America. And we
visualizations of the checkworthy factual claims, like what are the keywords in the checkworthy factual claims, what are they talking about? And we can compare like how the different speakers present facts. Is Trump presenting more factual claims or Fiorina presenting more factual claims? So we can compare them here. So let me show a comparison between Trump and Bush.
Western civilization to give them this agreement.
So
that the president treats like
here
the Magna
we can see
Carta,
the green color, Trump, is actually presenting more factual claims than the red color, which is Paul, and blue color, which is Christie. And
one of us on this stage
Bush also is kind of similar
not
to
honor that agreement
Trump.
and will destroy it.
We also have
because otherwise we put
try your own transcript place where you can copy paste your own transcript, and that will give you the score of things you write. For example, I rise. It has a small number. Definitely it's not a factual claim. Let me try another one. Sorry. So let me try this sentence. It has a different higher score than the other one we have seen. So yeah, let us know your opinion. Try with our demo, and let us know if you have any questions.
So just to explain how this fits into all the different pieces that we've done. So we have done at Duke several pieces that are about the analysis piece, and that is where we have developed tools that can help fact checkers analyze factual claims. For example, Will in the back has worked on a project about taking claims about voting records, and when someone will say Senator Kay Hagan votes with Obama 95% of the time, by perturbing the parameters of a statement, both its time period and comparisons to other people, you can get very valuable contextual information about that. So that's one piece of it. What ClaimBuster has done is answer a problem that we've had in the fact-checking community, which is the human challenge of going through transcripts and finding facts to check. So we do that at PolitiFact with interns. And so this is a way of supplementing the work of interns. Very labor intensive to go through a transcript and find these things. And so I had floated to the team the idea, man, can we do anything to help us, in effect, reduce the workload on interns? And this is what they came up with, and I think it's brilliant. So with that,
Hi, really lovely work. I'm completely impressed. What if politician says something and then say, in my opinion?
So from the journalistic standpoint, we would still fact check that claim. We don't feel like a statement of, in my opinion, is really changing the factual nature of that claim. They are still making a factual claim. I believe would be another one. We call that's no shield against a fact checker. I don't know, how would ClaimBuster handle that? Would it still rate that high?
Yeah, so that's a very good question. So it's actually a complex one with fact and also mixed up with an opinion. So yeah, probably it will boil down to how the classifier finds this as a fact or as an opinion, like based on previous history. And yeah, so it really depends. Probably it'll get a medium score, not too high and not too low. Yeah.
So we have time maybe for one more question.
So this is really beautiful. I think it's a fantastic work. But ultimately, to me, it feels like treating the disease rather than preventing it. And I should explain what I mean by that. In the world of science, if a scientist were to write an article and not cite their sources, we would just reject it outright. We wouldn't even let it be published and have people start to consume that and later go back and try to figure out what sources they're actually citing. Do you have any ideas on how we can incentivize political speech that is backed by references so that we don't even have to fact check?
So that's a good question, and we face that at PolitiFact. I'll show you some that's kind of interesting. So one way to do that is to look at people's record for accuracy. So now realize this is not social science, this is journalism. So these are all of the fact checks that PolitiFact has done of Hillary Clinton, and it's on the level of 120, probably something like that. And you can see that she has more trues and mostly trues at that end of the scale than falses and pants on fires. So if you change and look at Donald Trump's record, not so good. So I like to hope that this is an incentive. And if you look back in 2012, Michelle Bachmann had a very similar record to Donald Trump. The first 13 fact checks we did of Michelle Bachmann were false or pants on fire. I mean, she was like batting zero. And so So I believe in sort of the great marketplace of democracy that this begins to matter as fact-checking grows. We do hold them accountable for their sources. So the first thing we do when we do a fact check at PolitiFact, and I know this is true for the other fact checkers, is to go to them and say, okay, what is your source for this? So call the White House, hey, President Obama said this, and usually they're ready because now fact checking's matured and is at the point where they know they need to provide that sort of backup. And if they duck us, as Trump usually does, I think it's an indication that they don't have anything to back it up often. So anyway, so I think we're getting there, and I think we have to look at this over the long run. This is we're empowering democracy, and I think as fact-checking empowers democracy, I think that representatives and candidates are increasingly going to respond to that. So.
Fantastic stuff. It's great to see progress being made on this over the years. I think we need to cut off the conversation there. Let's thank the speakers again.
All right, so the good news is we've had some awesome conversations. The bad news is we are way behind time. So if there isn't any extremely strong objection, we're going to sort of jump past the break and go to the panel. So while the panel sets up, if someone wants to get a beverage or something from the back, this would be the time to do it. But we're going to jump to our panel, and then we'll jump right to lunch after the panel. All right?
Yeah, I think I would have remembered if I went to a drone conference.
There were grandmas outside protesting.
Really?
It was the first conference I've come to when there's protesting. It was literally grandmas against guns.
Oh man, I jumped in like
Just,
right as they were
like kind of
doing
like
test shows,
protesting drones.
and we did our first real show this week.
Yeah,
so it was like getting trial by fire.
The idea that the drone wasn't
haven't had much sleep.
Yeah.
Yeah, I'm glad you could join us.
Yeah.
I think I didn't realize that you obviously couldn't anticipate that the two things were going to happen simultaneously, but
yeah, that's what I was thinking, that you must be like super busy now, like this is the time.
It would have been
well, we
interesting to
worked
interview them and
last
see
weekend,
like,
but this
did they
weekend
think the conference was all people
they let us
talking
go.
about military
Well, lucky
But
for me.
they wanted us to work over the weekend because we didn't get a lot of time to prepare.
In a way, that was the scary thing.
The launch of the first
Didn't
week of
quite
shows.
realize that they would normalize
we needed the weekends.
Like
right.
Polish things
it was
up.
a really weird aspect of that.
Yeah.
This weekend off.
Where was it?
Yeah.
NYU. It was NYU. NYU Law.
Okay.
It started yesterday.
It did, yeah.
Does it run through the weekend or today's the last day?
I think it ends at 4 today.
Okay.
They have a
So maybe that's why
better.
protesters came out
They have a
too,
room
it was really
downstairs,
hard
the
to
brownies.
find.
They have a new room downstairs, I guess. Like
Or maybe the
that's
military
45
funded
or
it.
something.
Yeah.
So-
NYU law doesn't suffer for funding,
fun,
but
yeah.
yeah, it was a strange.
That's fascinating. Cool. Well, anything you should tell us?
Just talk. You guys are experts, so.
Okay.
I'm no expert.
I'm not an expert either.
Well,
I'll try to pretend that I'm an expert, if that helps.
everybody wants to know what Circa and I guess Daily Show, but
Yeah, very different jobs.
very different jobs. But
So you're with Circa?
I was. The company folded in May or June.
Yeah, I heard.
Yeah, and then I was unemployed for a couple months. And I just got a job a couple weeks ago at the Daily Show.
Oh, nice.
Yeah.
That's awesome.
So it's been fun. I came in the week they were doing test shows, which was 2 weeks ago. And we did our first week of live, well, not live, tape news shows this week. So it's been
That's awesome.
pretty hectic.
So what's your role?
I'm on the digital side. Baratunde Thurston was hired as the lead for the digital team, and I came in. I'm the digital production manager, so kind of like his operations guy for the digital team, trying to put it together. Yeah, it's fun. He has big plans for the digital side. Jon Stewart wasn't really a big fan of the digital side of things. But he's mainly focused on the broadcast, but the new regime is very much interested in building out a grand digital, almost a show outside of the show, the digital space. So it'll be fun to build that out.
All right, so Michael says we have to come back. So we have to come back because we do what Michael says. So maybe if we can find our seats again. We have an awesome panel that is between us and lunch. I don't know. I was like, I don't quite know how to put that in a way that doesn't imply something I don't mean to imply. So maybe if we can grab our Larry Birnbaum.
I wrote if I face people, I never remember what I'm going to say. But I'm not going to say all of it, but as like a quick introduction. But he said like 2 minutes.
Yeah, oh yeah, I have no idea.
Yeah.
I'm going to say hi.
Yeah, hi.
Are you around after this?
Yeah. Oh my God. All right, if we can take seats. Once AV finds its way, everybody, we'll start when Cheryl hits her seat. That's what we'll do. We'll wait. All right, so the next panel up is a contributed panel on ranking in an age of algorithms, and it was organized by Suman, and he will take away.
thank you. Can you hear me? All right. Good morning, everyone, and welcome to the panel on ranking in the age of algorithms and curated news. My name is Suman Debroy. I am the lead data scientist at BetaWorks, which is a New York City-based technology company, and I will be moderating today's panel. So before we get started, you all know this is getting live streamed, and if you're tweeting, please use the hashtag CJ2015. We don't have any slides for the panel, so hopefully there won't be any technical difficulties on the way. So 5 years ago, when I was a CS PhD student and collaborating with a journalism school, I first encountered the question, Suman, if you've got to talk about algorithms, tell us what it is for God's sake. Since then, most of the world, and perhaps more crucially the media, have discovered what algorithms are by themselves. there are still many opaque pieces in the conversation, and that's why we are here today. So over the past few years, we have noticed that ranking algorithms have unrolled into more and more content systems. But what we also know is they still lack tact. Their creators are too busy improving them, so they don't have enough time to explain them. And their interpreters have serious doubts about the underlying mechanism, which is why we are here today. So for me, this is one of the most important conversations of the year. So without further ado, let me introduce you to our fabulous line of panelists. First to my right, we have Anthony DeRosa, who was previously the editor-in-chief at Circa and has recently joined The Daily Show. Then we have Catherine Ignazio. She is the assistant professor at Emerson College in the Department of Journalism. And finally, we have Mike Juror from the New York Times. So folks, shall we begin with a short intro from you all, like the kind of work you do and your encounters with news feeds? Anthony, do you want to start?
Sure. So I backed into journalism late in my career. I actually started out as a developer, doing front-end work, mostly building websites. Then I went on to managing technology teams at different companies. I was working for a startup several years ago, which was acquired by Thomson, which became Thomson Reuters, and that's how I kind of got into working in newsrooms. At first, I was building products for news companies at Reuters, and then I eventually wound up working in the Reuters newsroom. I was their first social media editor, mostly managing the live coverage of events that were going on through live blogs on the website, and also overseeing a lot of the social media that we were doing, mostly in the data gathering in social media, not so much the marketing and promotional aspects of it, but trying to find news that was breaking on social media. Then went on to work at Circa. Circa was very much interested in trying to structure journalism, trying to build some ways that we can leverage the structured nature of how we were building out our stories, so we could do things like have smarter notifications, be able to reuse information in stories, and just be more efficient. And all that was really done with a focus on mobile. Unfortunately, Circa folded earlier this year, but I think a lot of the things that we were trying to do are now being picked up by other organizations, and that's nice to see. And about 2 weeks ago, I joined The Daily Show, which is kind of a much different departure, but it has a lot of interesting overlaps with things I was doing previously in my career. And we have a pretty ambitious plan to build out the digital side of things at The Daily Show. So can't say much about that now, but maybe come back in a couple of months and I can give you more on that.
Catherine?
Great. Hi, everyone. I'm Catherine D'Ignazio. So I'm an assistant professor, and I have a long title. I'm an assistant professor of civic media and data visualization, which I think is a very long and strange title. But my background is also in software development and actually in the arts as well. So I came to journalism by way of two somewhat unrelated things. And so a lot of my time now is spent teaching journalism students how to work with data in the classroom, thinking about tools, thinking about why, thinking about the news as an ecosystem. And I sort of came into news and quantitative news analysis by way of Center for Civic Media at MIT that I recently graduated from. And as some of you may know, we do a lot of work at Center for Civic Media on quantitative media analysis. We have a large database called Media Cloud where we're sucking in like 30,000 RSS feeds every day, doing entity extraction on those, attaching a lot of metadata to those so that we can start to try to look at kind of the whole of news coverage for things like bias along various kinds of dimensions, for studying how different kinds of crises unfold, and so on and so forth. So it's really like a research tool. And so when I was at the Center for Civic Media, my role was really building out the geographic elements of that. So I built a geoparser for Media Cloud, and I became really interested in the sort of uneven the uneven attention that different parts of the world receive, and even at the very local level, like I did an analysis called Mapping the Globe, which looked very specifically just at city and neighborhood variation and attention from the Boston Globes, just very hyper-local sort of news coverage. And so in sort of that kind of, building that kind of analytics led me to thinking about, well, we can do these studies, but how do we actually lead people towards opening up their kind of horizons instead of foreclosing them, or just like kind of studying like things about, I'm coming out of the arts, I don't like just like studying things, I like sort of trying to produce new realities. So for my thesis project there, I built an application called Terra Incognita, which was a Chrome browser extension which basically gave you a little bit of feedback. It gave you some personal analytics for where you read about in the world, but then it was also a recommendation system. So it would present you with cities that you had not read about, and it would give you like up to 5 things, or 5 news articles, ideally interesting, stereotype busting news articles that would tell you about that place. We can talk more about how difficult it was to actually do that and how well that actually worked. But that was sort of the goal, is to use our ability to extract geography from news articles at scale to present you with interesting, new, and diverse recommendations to kind of expand your horizons. So maybe I'll
That's great.
Yeah.
Mike from the New York Times R&D Lab.
Yep. So hello, I'm a data scientist at the New York Times R&D Lab. The R&D Lab's set up to think about the future of news 3 to 5 years going forwards. We try and think about social, cultural, and technological changes that might have some impact in the news business. My background is a bit odd, I guess. So I have a PhD in control systems engineering. I've applied machine learning and bioinformatics to sort of slightly strange places over a few postdocs, including one here with Professor Wiggins. After that, I worked with Hilary Mason at Bitly for a couple of years, thinking about what we might do with data that Bitly was collecting and how that could be used to show off the services of Bitly. And then from there, moved into the New York Times, where I'm supposed to be applying sort of new machine learning, new technologies to all sorts of different things that are relevant to the news business in one way or another.
That's great. Fantastic. So let's roll on with a few topics of discussion I think are important, and then we'll open it up for questions from the audience. So Mike, I wanted to start with you. We know that news feeds have become this sort of like marketplace for ideas, right? But a lot of folks feel uncanny that they are like controlled by algorithms to a large extent, especially Google News and Facebook. But we as scientists know that these algorithms are designed, and therefore there are explicit choices made in the design process. So let's assume like we have 100 incoming news links. How would you go about generating a ranked list from it? Like, what are the choices you would make?
Okay. So I think very explicitly I would try and decide whose problem I'm trying to solve. So I think understanding the context in which the ranking is going to be placed is absolutely critical. A lot of the work that we see is trying to solve the person who's developing the ranking algorithms problem. So, with a strong focus on like, click-through and trying to click on the topmost thing in the ranking algorithm. And I think generally that's the more fantastic way of going about it. So then I'm either trying to solve an editor's problem or I'm trying to solve a reader's problem. And I think those two things would be the basis for how I then go and start designing ranking algorithms.
And then that would involve you selecting the signals and then probably building a model that's sort of like predicts that.
Yeah, absolutely. I mean, oftentimes, so the ranking algorithms tend to take 2 forms, right? So I'm either going to assign a score to an asset. In the personalized setting, I'm going to assign a score that's relevant to the reader, or in a kind of sort of in the standard page rank setting, I'm going to try and think of some global quality that the asset has that I can use to make a ranking, or I'm going to try and build pairwise comparisons between assets. And how I actually assign the score, or how I build the pairwise metric, is absolutely defined by the context of the problem and whose problem it is that I'm trying to solve.
So it could be either taking the editorial perspectives into place, or the click-through, or ads, or whichever it is.
Right, absolutely. So if I can sense editorial in some way, which we've been trying to do for a bit, and that's a bit tricky because there's lots of editors, but if I can sort of sense the importance that a newsroom is placing on an article, then yeah, that's absolutely one way of doing it. Or if I can sense the popularity, or you can, as soon as you've decided whose problem you can solve, then the metric design becomes a lot of fun.
Cool. And talking about like ranking, I also wanted to talk about like internal ranking tools which recommend things that are happening to editors and to newsrooms. I want to ask Anthony, like you've worked in Reuters and Circa, are news organizations actively trying to build the sort of internal tools that go to social media and mine information and produce a rank list for editors to see what's happening and what's important? Mm-hmm. And like, what do you feel are the real challenges in doing that?
Well, when I first started at Reuters, there weren't a lot of tools being used, and social media wasn't as prioritized as a source for where they were gathering information. There was very much kind of an old school mentality about, using boots on the ground, which obviously is extremely valuable. There's nothing better than being able to see it with your own eyes. But the scale of information that's out there, the number of things happening simultaneously, there's no way for everyone to be able to experience those things themselves. So part of why I think they wanted me to come in and start to build out that listening tool, which is a combination, I think, of algorithms and things like Crimson Hexagon and just basically setting up your tweet deck in a way that you can monitor various things. I wanted to gather up tools like that, figure out where they could be useful, when they could be useful, and then it was actually a lot of teaching, telling people and giving them access to resources and showing them how to use them, having structured learning on a monthly basis. And the best part was after people would get their hands on those tools and understanding the value of them, having them talk to their peers and show them how they were using it and why it was useful. For someone like me who wasn't an experienced journalist, I can't show that I have these 10, 15 years of working in a newsroom. It's easier for me to take someone who has that 15 years of experience, is now using those tools, and can tell their peers, this is actually something you should be using and it'll help you do your job better. Right. And I think at Reuters that was something that I hopefully was able to accomplish. At Circa is much easier. It's a smaller team. People have already bought into the idea that these listening tools are extremely valuable. So that was something that we just kind of did by nature. We also had a very unique set of information that we were getting because of the follow function, which not many folks have. You could follow stories individually and follow the arc of how the story changes. We really put a lot of value in looking at how many people would follow particular stories, and that would help us focus our editorial efforts on stories that were followed by a large number of people. And I think that's an interesting signal that's more than a page view, more than a click-through. If you make an implicit choice to follow the arc of a story, you're really putting a lot of value in how much you care about that, because we're interrupting you with notifications. If you're eating dinner, you're getting a notification that the story has moved, and if you're willing to be interrupted any time of the day, that shows that that story is very much important to you.
So what's trending is in some ways critical for newsrooms to know, so that they can like write stories about it or focus on them.
Yeah, and I think we have pretty good signals, but not enough people are using things like the follow function because they don't have the ability to allow readers to follow individual stories. You can follow topics, you can follow entities, people, places, things, but I don't know of too many newsrooms that allow people to follow distinct story arcs. And I think that is a valuable signal that is not yet industry-wide something that's available.
Yeah, it's kind of fascinating that we have algorithms in social media, and although algorithms are like the quintessential example of all that's not human, but we need it so heavily to actually mine information from social media data. Catherine, I wanted to talk to you about Terra Incognita. Yesterday we heard a lot of interesting talks about regionalism in news and how local news is important. And to a lot of people, local news is obviously critical. It's not just about road conditions and the weather and things like that. But with data outside academia and data coming in from all kinds of sources, geographic information extraction is really messy because it's not always structured as the way you want it to. So tell us about the Terra Incognita project and your papers on that.
Sure. So Terra Incognita, in terms of the actual mechanics of extracting the geography, it's built on a technology. Well, there's a couple of layers, but we customized the technology that's called Claven, which is a geoparsing technology, which uses named entity recognition to extract places, but then combines that with the GeoNames gazetteer and then connects those places to actual latitudes and longitudes. And then so when we were sort of refining this specifically and tuning this specifically for news articles, we sort of added a layer that looks at the news article as a sort of atomic unit, and based on a very naive, we actually tried a bunch of different ways of determining the focus of a news article that were way more complex, but we actually have tuned it so that with about 95% accuracy, simply by counting the number of place mentions in a particular country, we can predict we can get the country of a news article with 95% accuracy, at least for the country level. And so that's actually out there. I would encourage people to use that. It's out there and it's open source, and it's called Cliff Claven because it's built on Claven, so we named ours Cliff. So if you have any use for geography extraction from the news, I would encourage you to go use it. And then so I mean that's sort of demystified a little bit the geography extraction. And so with that, the way that Terra Incognita works is one of the parts of it which actually made me uncomfortable was I get people's browser history, and I'm very upfront about it, but you have to look at their browser history to see what they've read about, and then go out and retrieve those articles and then extract the content and geoparse them and sort of see where they have read about in the world. And so once you know where they've read about, you can see where to recommend them articles about, which is what they haven't read about. And that's actually, the more messy part for me was really the recommendations and trying to figure out, well, how do you give people compelling things that they probably don't want to see, they don't know that they want to see necessarily. You don't set out that day wanting to read about Hiroshima or Accra or somewhere in Zimbabwe or something like that. And so then how do you kind of present them with that information in a way that feels sort of light and fun and low impact, but also compelling enough to potentially click on it. So it's kind of trying to solve for that problem of serendipity, at least along the geographic dimension of news. And so the recommendation aspect did in a bunch of different ways, both super manual, we were lacking a lot of high quality recommendations, for example, about cities in China. So we actually had a researcher manually compiling recommendations about that. We sourced recommendations from Bitly's real-time API, which unfortunately now is down, but that was a really interesting signal for seeing what was trending across the web, and then looking at that in relationship to geography. So if particular articles were trending in relationship to a particular city, we could source those. And then mining other users, the things that other users were reading, because of course we had their browser histories. And then we had a crowdsourcing campaign to collect interesting recommendations for places that we that were kind of our blind spots. So those are like Brazil and China and India in particular, which had a lot of populated cities that we were showing people, but then we didn't have the accompanying like interesting content to go along with them. And so, yeah, so that, I think that, so the geographic extraction was actually not as messy as the recommendation. I really feel like the recommendation was a little bit more kludgy in a sense.
Yeah, it's funny because we were trying to do something like extracting location from Twitter bios, and like the most popular bio was something like in your mama's house or something like that.
Yeah.
It was, yeah, things like that. It's
yeah, well, Twitter is okay. Yeah, so the named entity recognizer doesn't work as well on Twitter. So it's definitely more tuned for articles and kind of like standard
structured
grammar
yeah.
and stuff like that. Yeah.
Agreed. Talking about recommendation systems, Mike actually wrote a pretty good article about it on Medium. I'm just going to quote a line from it, which I really liked. Quote, "Your choice of algorithm isn't science. It doesn't absolve you from making other real choices. There are no fundamental rules of taste or behavior or desire that you're trying to uncover. No truths that will be truths next week or next year," unquote. So I think this is a really important line for what goes on in algorithms, and especially personalized systems where people's choices and people's opinions, their tastes will actually change very dynamically. And it's really hard to like use one data set, predict that, and like not have like an online system to learn about them. I want to ask you, Mike, if that's the case, sort of, it's so dynamic. We really don't have a very micro level understanding of the user. How do people usually evaluate recommendation systems and news feeds if they're actually giving any value to people?
How do they actually
evaluate?
So in my experience, people evaluate them by whether or not they get clicked on.
Okay.
So, which is great, I guess. But I would prefer if they evaluated them based on if the designer of the ranking thought it was delightful, right? Like it's a navigational mechanism. It's designed to appeal to humans. It should be designed by humans that think it's cool. I do get a little bit stressed when we pretend that it's science and not design. And once you've kind of freed yourself from thinking that it's science, you have such a bigger palette of choices then to make. So, yeah. So I think probably how people. The other thing is that people want to do click-throughs because of ads, right? So, getting eyeballs on pages is certainly an important thing. But I think probably there's quite a lot more to the design of these things than just how I typically see them evaluated.
So yeah, that's true. So on the product side, click-throughs are sort of the metric by which you see if it's actually working. What about from the consumer side? Is it like just feedback from users that you get, hey, this doesn't seem to be what I want?
Yeah, so you're definitely going to have feedback from your readers. I hear about people at the Times who get a lot of feedback from their readers all the time, and it's a big part of how they think. But there's also the design process. There's also the designers that are involved in building parts of building these web pages out, building these algorithms out, and testing, which is obviously another thing that people do a lot of, like A/B testing or bandit testing, is great. But it seems like it should be relegated to those bits that the designers can't decide for. So if there's a part of the website or part of the algorithm that you just can't tell if it's any good, A, that might be a good place for testing, and B, you've got a problem. Because if you can't decide ahead of time that it's not a beautiful experience or it's not a engaging list, then you're starting to cede your design power to some algorithm, some KPI.
Which you don't exactly know what's happening many times because it's either based on historical data and it's like learning continuously or something.
Well, yeah, I mean, you can definitely watch what it's deciding in its test, but I'm much more excited when people build things that they think are beautiful than than drop a bunch of ideas that they don't really have much feelings about into an A/B test and watch which one the robots or whoever's clicking on the things are into that day.
Interesting. So the other thing which we'd love to talk about is push notifications. To me, push notifications sort of seem like the ultimate personalization problem, because now you just don't need to optimize over the content and the user, but you also need to optimize over time. So it's an optimization function over three things. I was playing around with an app, I won't name which one, a few days ago, which sent me a push notification. And I sort of realized that it takes 7 taps on your iPhone to actually turn off the push notifications, but it takes only 3 taps to delete the app.
Yes.
So, so having that thing in mind and how it could be really an interruption to what the user is doing. Anthony, I wanted to bring you up on this. What do you think, how did Circle handle this?
We made that one of our biggest priorities, was doing push notifications better, because not just for news apps, for apps in general, there's a tendency to over-rely on push notifications as a means to get people to use the app more frequently. So we had the benefit of, I'll go back to the follow function as being a driver for the way that people could really customize the alerts that they were receiving. And we were less inclined to send push alerts outside of that, because we would rely on people to make their own decisions about what stories were important enough for them to be interrupted by. We did, I think, over the course of the about 3 years that Circa existed, we only sent maybe about 60 to 65 push alerts that weren't sent through the follow function, which is very few over a course of 3 years. And we only did that if a story was something that was pretty huge, where we felt most people would not have been annoyed by receiving that push alert. It's something that I think there's a big backlash now, and I think apps are feeling the brunt of that if they are sending poor notifications. I've seen studies done where the #1 reason why people delete an app is because there's too many unwanted notifications. So hopefully they're starting to think more intelligently about that, being less obtrusive, giving people more options. I think it's very much something that you need to rely on human beings in an editorial instinct about what should not be sent, and you should definitely be very careful about relying on algorithms to decide what push alerts are being sent and which aren't.
So keeping the human in the loop, I guess, is sort of the solution.
It's one of those things where, thankfully, our jobs are not in danger because I feel like that's one particular thing that really needs a human touch, needs to have the instinct to know that this is information that's going to be widely accepted and not felt as an obtrusive thing.
Interesting. Yeah, because I sort of like feel like a lot of the push, even from the New York Times push notifications, they are mostly editorial right now, right? They're really good actually because of the time, but when I pretty much know when an algorithm is sort of pushing it out, a lot of apps have that. They might not be news apps, and there's like at 11 p.m. at night, which is like really not what I want. So let's talk a bit about design again. I wanted to talk to Catherine about this. We know, like Google, for example, uses like more than 100 signals to rank content, but and they're mostly like the structure of the web page, keywords, headlines, phrases. It seems like they don't really have this like synergic journalistic priorities in there. I was wondering, and then you have Facebook and Twitter using the social network to do the same kind of ranking. So I was wondering if there are deeper signals like original content or originality or like opinion pieces or like data-driven pieces, things like these explainers. Is it possible to to have ranking systems that prioritize this, and should it be done?
Yeah, I think that's really interesting. I think it'd be great to see actually more research about like a kind of like a reception studies for recommendation engines or something like that, where we're really looking at not just like the clicks and not just like sort of what we can measure, like I mean, I know also people are trying to measure time on page now as a way to sort of round out just clicking as a metric, or just sharing, because often like people are not even actually reading what they share, right? I mean, there's some study that's like, we only read like 10% of what we actually share online. So it's actually not that good of a metric for how long we've spent with something. So I personally would like to see more of those kinds of studies and a slightly deeper qualitative and ethnographic work in that area, because I think that could really inform recommendation design and also bring us a little bit back to some of the more like civic and public service oriented goals that I think we still pay lip service to, but that sometimes get lost in the kind of new business models of sort of content and advertising online, and just sort of the way that the attention economy works now. So I would like to see more of that. And so I think like the factors that you're bringing up are super interesting, and those seem fairly feasible to me, that you could potentially design a system to say, like, is this a data-driven piece? Like, I could imagine you could design a system to try to determine that based on various criteria. Is it an explainer? I mean, those seem feasible to me if we wanted to do things like that. And I think the other thing, too, I mean, the thing that I think about a lot as well is thinking about how do we have systems that also modulate for their own bias. So, you know, we at Civic Media, we look a lot at the sort of systemic bias in the news. And so how could we design systems that present analytics, not, my Terran cognitive system was personal analytics driven, but how do we kind of treat the news organization as that kind of organism and say, well, what are the things that we are not looking at? Like, what are our blind spots? And we can use analytics to see those in various ways. And then how do we modulate our behavior based on those? So I think that would also be really interesting. We tried to convince one organization that I won't name to do this. But of course it comes down to like resources and time and these kinds of things. So I think that is another, but I think that's another area that is really interesting and is a thing to examine and incorporate into this kind of thing. So not just looking at signals and content extraction and stuff like that, but also looking at yourself. So self-scrutiny and reflection can also be really important.
Because I feel like some of these signals are easier to encode into the algorithm. For example, ephemerality, like, or the trust in the publisher, things like that. Some are harder, especially like how do you like detect explainers and things like that, which I feel like algorithm designers are like far away from doing that right now. But I also feel that they are sort of important in many ways to like actually give better content than maybe like listicles and what we were talking about yesterday, articles with titles that we could click on them. Cool. Mike, you want to talk about machine learning a bit?
Everything
Mike
about
is
it.
Like, yeah. It's interesting though. A lot of people actually ask me that question. That fundamentally, a lot of this ranking and recommendations, as you said earlier, that you work with machine learning systems. And a lot of these machine learning systems are essentially about some kind of parameters and finding the right values on those parameters. Is there a rule of thumb that data scientists use to like assign those parameter values, or do they like learn over time? Like, what's the trend there?
Okay, so there's two. There's two kinds of machine learning plays two parts in ranking. There's the kind of learning to rank machine learning, which if you Google learning to rank, there's a lot of work there, which is where you have some examples of good rankings that you approve of in whatever fashion, and then you try and build some sort of machine learning algorithm to replicate that ranking to new articles. So there's something, a piece of machine learning between something that you've already labeled and something that you haven't labeled and you'd like to get new labels for, which is kind of a lot of fun. And then the other place that we explore a lot more at the Times is the assigning of scores to a particular asset, especially in the personalized case. So the two ones that I haven't explored, but my colleagues in personalization have, is using things like topic models, especially if it's enemy text, if it's someone else's text that you don't have tags for. So using a topic model to assign a score, essentially, to a piece of content with respect to the person who's reading it. And then the other place, which my colleague Alex enjoys a lot, is the kind of new recurrent neural networks that people play with, which do a similar job. They essentially assign, they move the asset into a place that it can be compared with the reader. So those are the two places that I see machine learning being used. And to specifically answer the question, hell no, there's no like rule of thumb. So the topic models and the neural networks are by design really complex and have quite complicated learning rules, and we take off the shelf things for those. And then the learning to rank type of machine learning has, again, its own set of literature for picking those things. I would always be reluctant to use either, to be honest, when I'm doing a ranking, because they obfuscate the editorial, they obfuscate the value that you're trying to encode in the algorithm. So I would only use them, like I said, if I had enemy text that I really couldn't process some other way. I'm much more excited to sit down with some readers or some designers or some editors and try and decide on the scoring mechanism or the distance metrics that I'm using.
Because some of the things we've noticed, I think yesterday there was a talk about structured journalism. For example, if you're trying to cluster stories, and if you set the K value of like clustering to a higher number, it's gonna cluster things that are, not, like cluster two things that are not similar together. But if you set it at a low number, it's gonna like spread out. I guess a lot of people, essentially, that's the question which a lot of people who are not in CS ask, like how do you like set that value? It seems like it's mostly try out a bunch and then the one that fits works.
Yeah, absolutely. You find the one that you like. You find the one that you'd like to show to your readers.
Right.
I mean, there's lots of methods for choosing K and K-means. There's a bunch of different things, but my old supervisor here would describe them as kind of being not even wrong, which is you're trying to apply science to a website that you're building for people. I never quite enjoy it. It's always you muck about until you find the thing that's pleasurable that you want to give to people.
Right. And that's why there's a saying like all models are wrong, some models work.
Yeah.
So,
Box.
Cool. We'll have one more question here before opening it up to the audience. I want to talk a bit about reliability. So realistically thinking about companies like Facebook, using algorithms is the only way they could hope to exist or become as big as they have. Because for every post or every photo or every video that's uploaded, it would take years for humans to actually like look at that, the amount of data that they generate in like a day or a week. So with this knowledge, I still want to ask all of you the question of like, how do we improve the reliability of news feeds? Is it through real-time human feedback, like in YouTube there are people who flag videos that are, or is it through transparency or accountability? What do you think are the ways to improve the reliability of these news feeds?
I mean, it's tough to take myself out of the equation because sometimes I feel like I'm an outlier because my consumption is different than maybe the average user. But speaking personally, I feel like one of the things about Facebook that frustrates me is there's not enough options for me to customize the experience beyond what the algorithm. I think the algorithm helps, and many times it does bring the information that I'm looking for. But one thing in particular that frustrates me is, and why I tend to use Twitter quite a bit is I can build things like lists to really focus in on specific topics. Now, there are things called interest lists on Facebook, which most people don't even know exist. And I would be able to really focus on, a celebrity or a person in the news or a television show that I enjoy, or a genre of movies that I like. And it's those things exist on Facebook, but most people don't know how to get to them. And I don't think they provide the means to get to those things or provide tools for people to find them in quite a user-friendly way. So I think, like you said, that they would never be able to do this completely with an editorial hand. There needs to be an algorithm involved. I think design is something that's lacking a bit, and user interfaces, it needs to be improved a bit.
Catherine, do you have any thoughts?
Yeah, sure. So, I mean, I think I already said, like, I'd like to see more just research into what people think and feel about the results of these things. I just feel like there's a real lack of that. But then the other thing that I'm thinking about a lot right now is around the sort of data literacy and algorithm literacy question, partially because now I'm teaching students who need to be able, like, as journalists, go out into the world and kind of understand this as an ecosystem and understand the new ways to write for the machines that are doing these ranking and like traffic direction around the internet. And so I think that's like a tricky question. And so I guess in terms of the things that you listed, I would fall more on that side of like transparency, in the sense that like one of the things I liked yesterday, I think I made a comment about it, the presentation that was about personalization, where they gave the example of the Persilog system that's being developed. One of their design guidelines was that you still give the reader control. So you allow the reader, even if they're being personalized too, you allow that person a way to step outside of it and then see it from another perspective. And like the other term for that is perspective taking. So can we build perspective taking systems? So rather than locking us in without our knowledge into our own view, how can we zoom in and out and take other people's views? And it's something that's very tricky, and we can't really do that on systems like Facebook that are so completely built around these sort of atomic, individualized personal units. And so I just think there's like a whole host of cool design things that you could do in that space of things that would both serve algorithmic and data literacy, and also like have a real learning and sort of education benefit, especially if it's like a data-driven story or something like that.
Mike?
I guess I'd echo the desire for transparency, although I don't think it's going to happen.
Yeah.
Whenever we see especially the Facebook algorithm, it's always presented as like a machine with
even Lada's image of it was a big Dr. Seuss machine yesterday.
Every time I've seen it presented by people from Facebook, it's always presented as a kind of, oh, we don't know how it works. Like there's this big machine that assets go into, and they might show up on people's pages. And I think I'd be happier if they were a bit. Actually, they can do whatever they want, right? It's Facebook. It's a completely private platform, and so I like thinking more about the sort of wider platforms, the kind of more traditional news platforms, that they're more clear about the values that they're trying to embed in their algorithms, and at least then we can read them understanding those values, as opposed to the Facebook thing where we have no clue what their values are, what they're aiming for, other than more ads.
Do you think that organizations are, they hesitate to be transparent because they think their algorithm is going to be gamed, like Google? So there's a lot of SEO things happening there.
Yeah, I think that actually being transparent about your algorithms is next to impossible, because they're constantly changing and probably quite complex by this point. But I think about being clear about what you're trying to do with it is a different thing. But yeah, every system that goes on the web will be gamed, and that has been happening since they've been on the web. I think that's the fun bit.
Awesome. We have time for questions, so if anybody has questions, we need a microphone.
Thanks. This was great. I don't know if you folks are familiar with a paper that was published in PNAS a couple of months ago on the search engine manipulation effect. So it's basically the idea that if search engine results are biased in a particular way for one candidate or another, you can actually influence people's voting predilections. Kind of an interesting, powerful result. And I'm just wondering if you guys have had a chance to reflect on, what do we need to do as a society to start addressing instances where algorithms are actually influencing in a very tangible way core processes like democracy. So what should we do about that?
Well, I think social media plays a big part in forming opinions about candidates, political views, and there's a good deal of sock puppeting that goes on now. For those who aren't familiar, it's just basically, they're flooding some of these social networks with fake accounts that are putting out views or promoting one candidate or another, and sometimes if they're savvy enough and they can make them seem real enough, they can start to permeate enough people's feeds where they start to potentially change their views in the direction of one candidate or another. So I think that is something that needs to be looked at more closely by having an effect on how people form their opinions. And it also goes to the fact that a lot of these platforms don't want to get too far into the business of taking an editorial position. So how do they deal with a problem like that in a way that doesn't make it seem like they're taking too much of a stand? That's a tricky problem to solve, and it'd be interesting to figure out what the solution is there. But some of them are getting into the editorial business. If you look at what Twitter's doing with Project Lightning, and I think at some point Facebook, Apple now hiring people to manage some of the stuff that's going into Apple News. So we're definitely getting into a territory now where it'll be interesting to see where the line is between having an editorial hand in things and saying we're not a media company and we're just a platform.
Yeah, I'm just going to say, I think it's kind of a big problem that the main traffic directors on the internet are giant corporations that have completely untransparent and claim to be kind of politically neutral, and they're the ones that are directing the amounts of attention across the web. I think that there's a problem with that, and so I think that we need to work on addressing that, because in the end, I'm not sure, other than for advertisers necessarily, whose interests are being served. I mean, of course, they make some great products, but I don't know. I feel like that there need to be proposals for grand alternative ecosystems that could be possible.
Decentralized networks.
Yeah, just decentralizing. I think that's really the main thing, that the fact that so much of the it's not really information is concentrated, because the information is in different places. It's that the traffic direction is concentrated in so few players. And I think that's a problem, and I think we need to be paying attention to it.
I'll just add, I think literacy in these things is so important. The understanding of what's actually possible on the web. The Times actually has done a couple of really nice pieces about bot traffic and fake Twitter accounts, and all the phone verified account stuff was really nicely reported, and I'd love to see a lot more of that.
Other questions?
Cool. This is a question for Catherine. You mentioned the recommendation system that you built that was centered around exposing people to different types of geographical content. And this is you talked about using users' browsing history, which is really fascinating to me. It's involved in some of the work I do as well. But something that's always confounded me is I like to make the assumption that user browsing history is sort of independently distributed across the web. So then when we evaluate preference, we sort of have this, every link is equally likely to be clicked. And then, so then when we see what the user clicks, it's like, oh, well, they could choose from any one of 10 links, and they chose that one link, so obviously they must like it more. But that's obviously not the case. They see several links that are promoted on homepages or through social feeds, and that biases their selection process. So when you're looking at, when you looked, in your own experience, when you looked at geographical history, did you downweight certain things like most popular articles or articles that appeared were promoted in certain places? Did you upweight things that the user had to work harder to find?
Yeah, I mean, in the system, it was biased. Well, like it always showed them things that they had not read about. So I mean, it used their history to show them the opposite, basically. It didn't go so, it wasn't that sophisticated that it would look at a link and look at it in the context across all users or in the context of what was trending exactly online or something like that. But the one place where I did try to do some of that tuning, one of my ideals in the system was trying to prioritize sort of alternate news sources, not just the kind of mainstream large players. And so I compiled a short list of those, and then for when it pulled a list of potential recommendations, it would, if there was a link that was from one of those sources, for example, like Global Voices or kind of like an independent alternative source, it would prioritize those over other ones in the system. So that I guess it's kind of just having a short list of sort of trust sources whose content I personally wanted to promote. So.
All right, I think we have one more question.
So I'll preface this by saying, actually, I'm a big fan of machine learning. I work on it, and I believe in automation of all forms. But I just want to be a little controversial. I think personalization is overrated. Most of the time, we think we need personalization. We, in fact, are satisfied with a lot less. In fact, the example, I'll give you a quote from somebody who actually worked on physical newspaper, a chief editor of a very famous newspaper. And he basically said, when I actually give you a newspaper in your hand, I give you World on Shuffle. Right there next to a story about what's happening in your town, there is a story about Mogadishu. If you were actually always pulling information, you would never have gone to that information about Mogadishu. And basically, a curator is actually doing you a little bit of a service by giving you a little bit more. Conceding, yes, that we need to find curators that we trust. In the old days, another editor basically said, he basically showed me a picture of the Hearst Castle, said, this is the bastion of information, they control it. In present day, they showed a picture of Larry, Brin, and Larry Sergey and Zuckerberg. These are the bastions of information. Another part of this was, in the old days, they used to say that if I'm a newspaper person, I'm bound to the truck delivery people to deliver the news, because that's where the unions are. Now I have to worry about web services. So the world has changed, and I actually want to kind of come back as personalization is overrated. What do you guys think?
Well, we tried to break the filter bubble of people over-personalizing and staying in their own biases by the feature that we had in Circa was called Wire, and it was a 50-50 split of these are the things, sort of like the old school newspaper. We program the front page, and we think these are important things that span the world, not just the corner that you live in. That would be half of what you're delivered, and the other half is the stories that you were following. So I agree with you that we can spend too much time over customizing and really not opening people up to things that they're not accustomed to seeking out. I think you spoke to finding ways to break out of that filter bubble as well. And yeah, I don't think anybody on this panel would disagree with you that over-reliance on customization is actually a really bad thing, for sure.
Yeah, I don't disagree with you. I don't think personalization is necessarily going to solve that many problems. I actually think it's like this over-reliance on, again, like reducing everybody to an individual. Like, we're not just individuals. We participate in all these different kinds of communities. We're affiliated with different, interest groups or schools or religions or whatever. And those are, it's like almost like we're designing for individual people. Why don't we design at like a slightly higher, like a different scale, like personalized for a community? Like, what would that look like or something, And so So I don't disagree at all. And I would also offer that like the app right now that I like the best is completely not personalized. It's just the Yahoo News app, which just gives you like 10 stories a day, and they're chosen by news editors, and there's no personalization. You can pick international or domestic. I think that's like the only option that you have. But there's something nice and concrete also about limiting choice and kind of limiting and giving high editorial and curatorial voice. I very much value that, at least as a user. So.
I guess I would argue in that particular case that personalization is actually one of the exciting moments for personalization. So the lovely thing about the paper is that you know when you're done, you've finished reading the paper, and you've got what you're going to get for the day, and you can relax for the rest of the day until the next paper comes. So in the setting that we work in now, when there is no end, we have a stream of assets, even if they're quite a tightly curated stream of assets. I should stop calling them assets, shouldn't I? That's terrible. That's a terrible data science way of thinking. Sorry, stream of articles. The personalization role there would be to make sure that the stream that I'm receiving understands what I've been reading, and so that I can get to a sense of completion within a never-ending, occasionally get to a sense of completion within a never-ending stream of articles, and that I think is actually a really exciting opportunity for personalization. Most of the personalization I see isn't really very personalized. It's more kind of segmented, which is like herd recommendation, which I don't enjoy at all.
Right. I think we're ready to close the session. Let's thank our panel for coming and sharing their expertise today. Thank you.
Thank you so much, and thank you for organizing, Suman. Lunch today is downstairs in the space where we were last night, so I think it's probably going to be a little warmer in there because we can control the AC a little more fidelity. And we're going to come back at 2 o'clock. So although we're starting late, we're coming back at 2. All right? See you in an hour or so.
Yeah, you're a man from Brooklyn in his 30s.
Right.
So,
Right.
Yeah, it's not that bad. It was worse last night. Jersey City. So that's I'm just going to take the ferry back.
Right. Well, that's like what they showed. I don't know if you're here. Yeah. Yeah, they showed that first blog. It was like that, basically. Like, if the person is such and such. Hey, really nice to meet you. Here, let me give you my card.
Yeah, I think we'll probably be reaching out to you guys because Barrett's really was interested.
Okay.
So, I don't have any cards yet, so.
Well, yeah, get in touch.
I'll reach out.
I'm going to be proud that I met someone from Daily Jobs. I think that's really cool.
I'm glad I met someone from MIT.
Here's your cards. Yeah.
I do try to do the cards. I'm showing my wallet is right now.
I know.
Hopefully Alex was looking at it.
Sorry for pushing you under recommendation.
Oh yeah, I didn't feel pushed. Oh, okay. Which one were you worried about? The quote. Oh no, that was hilarious. Yeah,
I thought it was a great argument.
Yeah, I didn't realize you were going to read it out.
No, it was I feel that's very true. It's just computer scientists don't want to acknowledge it. Like, they're like, oh, I want to get them checked.
It's fun to be comparing discussion.
is there, I hate to ask, but can you go downstairs and make sure if anyone's down there, they know we're starting? Thank you. So this session, we have this session and then our keynote, and I believe our keynote speaker is in the house. He was just here. There he is. Oh, so adorable. Okay, so Meredith is going to be hosting this session, so I'm just going to give the mic to her.
Okay, thank you, Mark, and welcome everybody to our afternoon session. Right now, we are going to be talking about visualization. Data visualization, of course, is a really important part of data journalism, and we're going to be talking about visualization for story finding and storytelling. So our first speaker is going to be from RevX, and which RevX participant are you? Okay. Christian Felix from RevX is going to talk about visual investigative journalism with 1 million healthcare reviews. So thank you.
Do you have an adapter? Sorry. Can I use this one? Okay, so good afternoon, everyone. I am from New York University. I am here today to talk about RevX. That is a tool that we developed in partnership with ProPublica. And ultimately, this tool was used to generate one of the articles that was published on NPR Radio in August this year. So ProPublica came to us with one big data set, so 1.3 million of healthcare reviews that they got from Yelp through a partnership. And they had one question. So how can we explore this data to generate some interesting stories? So they have first questions about how people do evaluate the healthcare provider. So how different categories of health are evaluated, how the top healthcare are evaluated, and also which words characterize some specific types of reviews. So if I select 1-star reviews, which words are relevant to this review? If I select 5-star reviews, which words are relevant to this one? And also which words are relevant for each provider category. But not just that, so they also want to find relevant information. So search for people that maybe had some experience with some drug or some treatment that can be interviewed for a story. And also maybe spot some doctors that are prescribing wrong drugs or doing some violating some laws. And if you look to the Yelp data set, we will see that every review contains a text, but also contains some structured data, like the date, the rating, the user, the state of the user, the name of the provider, the category of the provider. So we wanted to take advantage of both data, from the text and from structured data. So we wanted to develop a tool that could explore this data and let the user come from a very generic idea to a more specific one. So we decided to use a exploratory search tool that first allowed the journalist to create statistical analysis, so see how the data is distributed, how the ratings are distributed, and also search for some keyword. So if I'm interested in prescription, if I'm interested in some drugs, I can search for the name of the drug. And whenever I do that, I wanted to segment the data and see how this new segment compares with the overall data set. So if I segment the data for 1-star reviews, I wanted to see how 1-star reviews are different from the overall data set. And through this process, going from a more generic to a more specific, I wanted to find interesting reviews that I can use to my story or find interesting people. But we have to deal with two problems. First, noise. So this data, people don't use the same language. They sometimes write just one line of text, and we have to deal with that. But also we have to deal with scalability. So we have 1.3 million and growing, and this data is updated daily, so we have to be able to push this data as fast as we can to the tool. We don't have time to spend with much pre-processing. We wanted to enable them to explore the most recent data possible. So with this idea in mind, we create RevX. So RevX first allow the user to search the structural data using faceted search, but also allow the user to explore the text data by searching for a full text for any keyword or any combination of keyword he's interested. So from the faceted side search, we also have statistics for each facet. So if I am looking for the rating on the top, I can see how many one-star reviews, how many two-star reviews we have. At the same time, we can see how the proportion compares with the data set. So I am searching for prescription, and I can see that when the word prescription happens, people usually give more one-star than five-star reviews for some reason. We can also see other information like the provider. We can see the category of the provider. And also we can see the original text. So we can see the full review and try to understand why the user gave that rating. On the right side, we have something that is pretty important. We have term suggestion. So whenever I search for something, the system compares this result with the overall data set to find interesting words or relevant words for this segment. So for example, since I search for prescription, I get pharmacy, I get medication, words that are related with prescription. And this is very helpful because then the journalists don't have to read our reviews. It can start for some ideas and some words that can lead him to the more interesting reviews. So I'm going to show you a video on how the interaction happens. So this is the tool, and this data set is actually the academic data set, so we have restaurants here as well. So the first thing we wanted to do is to select only healthcare and medical. So I can select this data, and I get only reviews for that, and I can see that the significant terms now show things like doctor and patient, and we can see the distribution of the ratings, and we have more one-star reviews. So I wanted to find what is wrong. I can search for the word wrong. And on the right side, I can see some new words. And we see that insurance, we see prescription, and something is wrong with that. So maybe the insurance did wrong, didn't pay something, or the appointment was wrong. So I search for one-star to find only bad experience where the word wrong happens. And I find the word prescription, but I also find insurance that are also wrong. So, and also people talk about the doctor. So the idea, let's select prescription, and we can see documents where we have text mentioning wrong prescription. And we can go through the test and find the one that may be interesting, see if this data is valid enough, if I have support to use this data. So for example, we can find this one. In the end, he say, oh, be aware, misdiagnosed and being prescribed wrong prescription. Okay? So this is a way to explore the tool, and the journalists used this process to find interesting information. But the point is, this data is not proxy for the truth. I have to validate this data because, as I said, we have a lot of noise. So every time they find some statistics, every time they find some interesting information, they either contact the provider or contact the people, or maybe research in third-party venues to make sure that that information is valid. And through this process, this is an interactive process. It keeps going until they are satisfied with all the information. Then they wrote their first article to the NPR talking about how people are evaluating doctors. So I would like to share you some findings that is presented on the article. So the first thing that we saw before, we have a skewed distribution towards five-star reviews. So people give more five-star reviews to healthcare providers, but also they give more one-star when we compare with 2, 3, and 4. So this means that people usually talk more about strong experience, or strong bad experience, or strong good experience. People don't like to share normal experience or average experience. We can see also that the top providers, most of them are below the average. So the average of the data set is 4.0, but 8 of the 10 top providers are below this average, and the 2 ones that are above is actually about acupuncture and massage. So they are not like hospitals or doctors. We also have so we can see that the number of reviews is growing exponentially. So half of the data set come more from 3 years, even though Yelp dates from 2004. So this is interesting because the data is growing and we have more information to mine. So something that they find, why doctors receive one-star reviews? So first, Long wait times, so if you spend a lot of time waiting to be seen. Second, getting an appointment, so sometimes you call and you don't get answer. And also the staff were unprofessional. So we can see on the right side relevant words for 1 star, and we can see that most of them are related with that. We have called, we have appointment, we have rude, we have time. Time is even more popular than doctor. That's supposed to be the most popular word since I'm rating a doctor. So, and we can see below someone that say rudest office staff ever, also incompetent. I can settle for rude and incompetent, or polite and incompetent, but both rude and incompetent is unacceptable, okay? So, and if we go, so this is important. One thing that I wanted to mention here. People are not rating doctors because they gave the wrong diagnosis or because they weren't good. They are rating doctors because the staff or the office or the organization weren't good. So, but doctors respond to that. So some doctors even have response teams to work in Yelp, answer some reviews. And we can see that this first user actually rated the responsive team. So someone get in contact with him, and then he tried to answer, and he tried to answer twice, and he didn't get any answer. So the doctor get another 1-star review. So some doctors also file lawsuit against some users. And in the article, they actually interview one of these users because they have bad reviews. And some doctors also, we found a review where doctor offered money to the people to remove the review because the doctor can't remove. So he asked them and said, okay, I can pay you if you remove your bad review. So overall, how the journalists found the tool? Is this useful? Okay, is useful or not? So first, they say it combines a lot of many tools, and they like the idea of doing statistical analysis with textual analysis, and also the tool help them to slice and dice the data. This idea of segmenting and get information of the data is very important. Also, they think that this idea where exploring large data set is a model that is important for many journalists, and they think there is a tremendous applicability for that. When preparing the story, they said, oh, the tool was invaluable to the creation of the story because most of the data come from there. So overall, what we think about user-generated content. And so we saw with Yelp that this data is useful and is increasing, and this means that we can get more and more data. And we can work with different domains, not only Yelp, but Reddit, ZocDoc, even social networks like Facebook, and different, like rating movies, or not only doctors, or not only business. And actually, there is a new software being released where you can actually review your friend. So today, they review everything. So, but the data provides not the full history. It actually provides signals of things that we can investigate and get new information. So we have to contact people, we have to contact the provider to get more information and check if that is right. So it requires validation. So from the Revex perspective, although Revex was created to work with Yelp, it actually works with any combination of text and structured data. So we can work with all the other data sets that we have as well. And if you have any kind of data set in this way, we are happy to partnership and see how Revex can help you to solve your problem. And I would like to thank you, and thank you also Yelp to provide the data, ProPublica to be together with us, helping us with this project, and also New York University, where I'm from. And if you have any questions, you can ask, or you can go to the website and access the tool and see how the tool works. There is information about the article there as well. Or you can contact me, my email is below. And thank you so much.
Thank you, Christian. And do we have a few minutes for questions? Do we have some questions from the audience? This is a very impressive project.
Thank you.
So I'll lead off with a question. So how did you get partnered with ProPublica to do this project?
So ProPublica, my advisor, Nico Bertini, he has a podcast, and he has one interview with Scott Klein. And Scott Klein said, oh, we have this data set, we are interested. And we work with text visualization at NYU. So this is not our only project. We have another ones in partnership with other organizations, include United Nations. So they say, Enrico said, oh, this is an interesting problem. We wanted to help you. So let's try to work together. And this started, I think, in May or April. And then we went to ProPublica, we interviewed them, they said, oh, these are a problem. And through these meetings, we get to these final features that we need, and then we improve to this tool. And today, this collaboration is still going, so they have new features that they are requesting, and we are help, and they are thinking in creating new stories using the same data set.
Yeah, just curious. So for doctors, it was mostly 1- and 5-star reviews. Is that true for most things, that people only report the good and the bad?
Yeah. So actually, if you look for restaurants, the distribution is more like a triangle. So you have more 5, then 4, then 3, then 2, then 1. But this is not true for doctors. So for doctors, the 1-star reviews is very different from other types of reviewers.
Okay. Just some comment that the J distribution, where you see the highest number of 5s and then the second highest number of like 1s or 4, that we see in other review systems as well. So it's like the J distribution is.
So you mean this one?
Yeah, like that's sort of commonly seen in other literature. But I was wondering, you mentioned for the doctors who receive 1 star, people were complaining about the time and like the common things, but not necessarily about the disease, because maybe they don't have the expert knowledge to judge that. But I wonder if the same kind of comments were made about the doctors who received 5 stars. Maybe they were happy about the quick response time, and so maybe the topics that were discussed were not so much different for the 1-star to 5-star. Just curious.
Yes, actually, yes. So most of the time so 5-star reviews sometimes are shorter. So people just say, oh, this doctor is great, the officer is beautiful, and so on. And when you have 1-star reviews, the text is longer, so they try to explain more why they are giving 1-star reviews. But also just happened with 5-star reviews. So people give 5-star because the officer was beautiful, or not only because the receptionist attended them and they was on time and all this stuff.
I've heard people, like small businesses, complain about fake reviews on Yelp. Is that something that you came across in your research at all or dealt with? So
actually at NYU we had one project trying to detect that using machine learning, but they get some results, but not that impressive. So Yelp they have a machine learning algorithm that tries to detect fake reviews, but that is also not for sure the 100% correct. We couldn't find one that we can see and say, oh, this is a fake review. So we would have to learn more about what characterizes a fake review, because just looking to that, we don't know the user, we don't know the provider. So just looking to the text is very hard to say that this is a fake review, because it's supposed to not look like. So in this case, we need more machine learning, more pattern exploration to detect this type of reviews.
Okay, thank you very much.
Thank you.
So next up, we have a presentation by Lenses. Lenses is an open source data visualization tool. Okay, so our presenters here are Helen Carey and Nivedan Selvan. All right, didn't butcher it too much. Okay, thank you.
Okay, so we are presenting a very early stage project that came to, well, Lenses is a tool for data visualization, and I'm actually going to tell you a little bit about the history and head back to this slide in a second. It came through the NYC Media Lab program, which is a private-public partnership between media organizations in NYC and academic institutions. So the initial code was developed in News Corps. They came to the NYC Media Lab that contacted NYU Engineering and the Columbia School of Journalism to kind of build out and pilot this tool. So over the course of last semester, several students, both Nivedin and I, worked on components for this system. We applied for Knight Foundation funding over the summer, and we are going to hopefully get a lot more hands-on time with the project in this coming semester. So what it is, we hope to make a community platform where journalists can partner with developers to create visualizations from data sources that they find particularly interesting. One of the things that we worked on last semester were input units that had APIs from, APIs from popular data sources baked in. So for example, I worked with data from the Sunlight Foundation, which tracks upcoming bills and demographics about Congress. A journalist could then use this input module and use the drag and drop and WYSIWYG interface to perform filters, input that data. I'll give you a demo in a second so you can see what I'm talking about. But the point is it makes data accessible to people without having to code SQL. The interface is a tabletop-like application. It has 3 types of components. You can drag in input components, which take HTML table data, CSV, transform components, which perform your usual transforms. They're pretty simple at this point, but like column splits and joins, all the sorts and filters. And then we have visualization components, which I hope to work on more this semester. Right now we're kind of doing both, just the basic charts and graphs. But by having this easily modified, modifiable interface, we hope that people can experiment with different ways of visualizing the data and different ways of sorting to try to make sure that they find the data that they're looking for, as well as save the lens as a chain of events that they can then send to their editor or their collaborator to check the work. Okay, so I briefly introduced the key players in this project, and take it away.
Okay, I'm going to be talking a little bit about the core philosophy of lenses that we hope will make it different and unique from the other data visualization tools that exist out there. The first core philosophy, I think, which is extremely important in journalism, is a way to preserve the history of how the source data was transformed into whatever graph or chart or any visualization that you see. So anything that's created in lenses, it's like a pipeline where you have like this input component that flows through a series of transformation components, and finally you have this output that you can show, and every single output is linked back to its source data through a definite series of transformations. And you can, at every single point after each component or after each transform, inspect what the input and output is like to just verify it. And the reason we think it's extremely important is because if I want to make a visualization, send it to my editor, or even release it to the readers, they can know exactly what you did with the data. And you can do a bunch of whole different things with the same data, right? So this is roughly what it looks like. There are like, these are just like an early prototype, which is, there's one form, which is like a 2D freeform thing where you can like just place around a bunch of components and then connect them together and just, they give a definite output. Or there is this other prototype which we're also testing because some people thought this was too complicated, is where it's just going to be a linear thing where you just you can't have that fancy split that you see right there. The second core philosophy is for people who want to work on developing components. This is mainly people who know how to do a little bit of code. If you want, we will have like a set of components that we will be building and like offering it up in the platform. And if it is something that you are specifically interested in doing something very specific to your data, you can easily, let's say, fork an existing component and build on it and republish it back to the community that can be used. And all of this, the whole project is going to be open source. And the third part, which I think is a different kind of open source, in which the way that each visualization is created is also something that we want to be open source. So we kind of want to create like a GitHub community model where like a bunch of people get onto this platform and make these visualizations. So this was something that a bunch of journalism students did last term. We were just working around with this. So most of the names except Nisha are all journalism school students. We were just like trying to like test out the kind of stuff that they wanted to do with data. And this is like an early prototype of what it would look like. It's going to be much more prettier than this, I hope. But so you can just see each of these visualizations. You can click the edit thing, and then it brings up exactly what that person did. And you can fork it into your own new visualization and change it as to however you want it, and publish it back. So now let's go to the demo.
Yeah, I'll give a demo. This last slide was to reinforce the fact that we hope this is a collaborative community and that developers can work with journalists to make some really cool visualizations. Unfortunately, our app is being a little funky today. I have some visualizations loaded up. I'm going to try to do some of this live. Google Update, it's built on Google Polymer, which was updated over the summer and broke a bunch of our backends. So what we have is mostly working. So what I've done here, one of the ways to input new data is just copy and paste from an HTML table. So I pulled up a table of home price changes and pasted it into, pasted it into this input module here. If I wanted to, say, find the average per state change, which states had the highest average change between the years, I have plenty of components that I could use. One of the first things I would do, let's go back to the table real quick. We have just metro areas here, not states. So one of the first things that I would do would be perform a split to split out the city from the states. So going back to, going back to my tools here, there's a split by column. Please work. Or not, okay. I can walk you through one that I did, that I did right before we presented. Okay, same data, inputted to the table. From there, I did a filter sort for everything that had changed more than 3% from Q3 of 2013 to 14. After that, even though I hadn't split out the states and cities, Google Maps is, Google Maps is able to grab the longitude and latitude if I wanted to map this very quickly. So I was able to just select the geocode function, and it populated these two columns here. And then the last visualization slide here is a Google map with pins dropped in the long and lat slots. If we have a few minutes, let's give this a shot. Copy, paste the table. probably didn't have headers there, which we may be able to do without. Okay, so the split would be here. Unfortunately, I don't have headers, but I'll just kind of show the functionality. It would be on that first column. Here is a split by comma. I know we do have other splits. I think the comma is the only one that's functional at the moment. So I would type in the names of my new columns. The city is first, the state is second. And so when I grab the next module, which, let's see, you can see that they have been split out into the different categories. And actually, I think I want to do a group module. So I would go back up a step, pick group data. And here, now that I have the city and state category, I can group them by state, and I can apply a function. So in the first case, I wanted to look at which states had the highest percent change in home prices. So I'm going to average by state. Let's see, on column percent change, and I'll go by ascending. And we have this calculated column, which I hope is right. We'll graph a bar chart to see if things are coming out okay. Only this chart is working, so it's not the ideal chart for what we're trying to do. We definitely want a bar and not a line. And here we can, and let's see, is state being shown? Okay, and so here we can see state on the bottom, and as we roll over, we do get the interactive D3 type coding of our data in our graphic, and this graphic would be easily shareable, embeddable. The code is saved, and with it, the provenance is saved so that all of the steps that you've taken are there. And that's what we got at the moment. We do look forward to making a lot more headway on this semester. Oh.
Thank you very much. And we do have a few minutes for questions. What kinds of questions do we have for the Lenses team?
So in your philosophy, do you think journalism companies should make their data public when they do Freedom of Information Act requests and stuff like that?
Well, it's not necessarily. So that's why we hope to have like a GitHub kind of a model. I mean, all of this is not something that's been like top down, well thought out yet, but we would like to create that kind of a community. But otherwise, we also hope to have a kind of like a private repo kind of a thing that you can get probably, as a paid subscription or something like that.
What we had worked on up to this point was just working with the OpenGov data sets that are out there, which are not always easy to work with. It can be a pain in the butt to bring it in and perform the filters, and so that was kind of the impetus for the API baked in, just to make these data sets that are out there and in the public immediately usable. So that has been our focus to this point on the development side.
Okay, more questions? Here you go.
I need to start saying that this looks very promising. I'm here from the industry, I'm here from Philips Research, and I can tell you that what you have done, it's not only for journalists, but also for the industry, it also looks quite promising. I have only two questions for you, if possible. The first one, have you tried to experiment with D3GS to make your graphs a bit more, I don't know, lively or animated? Have you looked into that area?
Yes, we have a few components in the work. They're not ready to go yet. But yeah, we do hope to make them like interactive and interactive on touch, so that if they were, put into a story as an interactive.
Because that would give a great boost also for the lively factor of what you are doing. And the second is, does it scale? I mean, I can tell you also from, maybe you also have it in your domain, but in the industry we are dealing with huge bunch of data, especially from like claims data or from medical providers. We're talking about 1 million records of data. I wouldn't dare to upload such a file on this application. Have you thought about this kind of situation that you are dealing with really big bunch of data? How would you deal with that?
That is not a case scenario that we have, like everything right here runs completely on the client side. So that's not something that we have factored into account in our early prototype. And the same goes with D3 too. I mean, we just wanted to show that it's workable. We just wanted to show some graphs rather than pretty ones. But of course, it's something that we should definitely work on.
Yeah, the biggest one I did last semester was the New York City 311 call database in the open NYC set, and I think it's like 10,000 records, and it could handle that. But yeah,
It might make sense to separate the data model from the presentation model.
Yeah.
At least. But yeah, it looks very promising. Keep up the good work. Thanks.
We have time for one more question. Yep.
This is really interesting and great, and especially going back to kind of your core philosophy about transparency, and perhaps you've already been thinking about building this in, but are you also ingesting or bringing in not just the data, but the metadata about that data? So the source of your table, any information linking out, link back to that agency or documentation about how you got that. So the 311 database that you just mentioned, if you had to actually go and call the agency to get that data and bring it in, kind of documenting that, and is there a way that you could consider maybe building those input fields into your system?
I think that's a great point. We haven't done it to this point yet. Right now, it's just preserving the URL and. Does it bring in any other metadata?
So we have a bunch of different ways to input it, right? So one of the, all the APIs inputs that we have baked in, and the URLs will preserve that. But for stuff that you copy paste, for what we did right here with home prices, we haven't thought about, we haven't built it in yet, I guess.
Even just a good citation.
Right, yeah.
Good strong data citation would be real helpful. And that would increase the transparency.
Thank you.
Thank you. Yeah, that's a good note.
Okay. Thank you very much, Lens's team. So our next speaker is going to be coming to us electronically. This is going to be a talk about tweet location detection, which is a thorny problem. And Mark is going to bring our speakers up on the screen.
Okay. Do you have reflection of my voice? Do I need to put headphone on, or is it okay?
I think it's okay.
Okay.
Nobody seems to be disoriented. There's no... Okay, you're on.
Okay, perfect. Okay. Hello, everybody. It's kind of weird because I'm not seeing you, so I'm seeing just a door or something in front of me. So my name is Bahara Harabi. I'm just going to share my slides with you now, and hopefully it will all be good. Yeah, you got my slides? Okay, I'm going to present our work on Twitter location detection, mainly for small event visualization. This is a work which is done in my group at Insight News Lab that I'm going to talk about a little bit. And the paper was done by myself and Ihab Saladeh, who was at the time a research assistant in my group. Okay, I'm a research group leader at the Insight News Lab, which is a research group mainly focused on a lot of computational journalism, future of news, data journalism type of projects. It is part of the Insight Center for Data Analytics, which I'm also a research fellow. Now I can see that. I'm also, I also teach data journalism at National University of Ireland in Galway for the MA in Journalism master's degree. And I also teach data journalism as a sessional lecturer at the Dublin City University. I'm the formerly data scientist and kind of a data journalist at the Irish Times, and I founded the Irish Times data blog, and I'm the founder and organizer of Hacks Hackers Dublin. So the motivation behind this paper is a visualization that we had at the Irish Times when we started the Irish Times data blog. We wanted to be kind of cool. A lot of people at that time were doing Twitter visualizations on map, especially like Car2DB type torque maps, and we also wanted to do one of them, and the news editor suggested that why do we not do it for the Irish, Ireland and Scotland football match. So I kind of decided to do that, but for that, the main question for us was, so these are examples of other types of visualizations that I'm sure a lot of you have already seen. And a lot of them are from Twitter itself or from the Guardian data and those sort of places. One thing which was important here for us was a lot of these data visualizations were about visualizing large events. While our events in Ireland would be considered as small events because the population of Ireland is 4 million in total. And if we are talking about Ireland and Scotland football match, it's around, in total, it is not it's not even 10 million people. So the number of tweets that we will get in a data set is really smaller in comparison to when we're talking about events such as elections or very popular football games like international football games, etc. So this was the visualization that I did. This was the result, and I'm going to explain how we did it for such a relatively small data set. The main thing about a small data set is when we have a lot of tweets, the number of geolocated tweets is also relatively high with respect to the whole data set. But here, we would have very small number of geolocated tweets. And in all of the other visualizations that I just was showing, what they did, they used the tweets which were already geolocated. So there was nothing done on the tweets data sets for geolocation or for location detection, because there was already a large pool of tweets with geolocation information. So here the main question for us was, where do we get this location from, and how do we map it? So we decided to go ahead with Car2DB as the tool that a lot of other visualizations were also using. So the main question here for us was, how do we get the location information? One was to go with the same approach that as other visualizations and to do the just normal only tweet visualization approach, geotag tweet visualization. The other kind of obvious approach was to use services such as Car2DB Twitter map, which kind of provides very, very easy to use tweet collection and georeferencing tool. But there is a problem with that I'm going to explain later. If we went ahead only with geotag tweets, depending in the literature, they normally report around 1%, but our data sets, some of them are showing around 4.5% of tweets. So we consider between 1 to 5% of tweets are geotagged. So if we are talking about 1 to 5% of tweets, if we have 1 million tweets, if our data set is 1 million tweets, then we get around between 10K to 50K tweets geotags. And if we are going to visualize them over 1 minute of kind of a torque animation, we will have between 167 to 800, around 800 tweets per second, depending on our geotag tweet rate. So if we are talking about 200 tweets per second visualization, it is going to be a very interactive and very interesting visualization. But if we go down on the number of tweets, and if our data set is smaller, it is different. So if our data set is 100,000 tweets, we will have around 17 to 83 tweets per second. 83 is pretty good, 17 is not so good, could be still quite boring. If our data set is 200,000 tweets, if we go with 1% rate, we have only 3, we might end up with only 3 tweets per second or 5 tweets per second. And this is going to give us a really, really boring visualization. And what we had in our data set was, in the case of the football match, was only 22,000 tweets. If we go with 8,000 tweets, which is another data set that we had, and I'm going to present here, we will end up with 1 to 5 tweets per second on average in all of the 1 minute, which is extremely boring. Basically, there's no point in visualization. So if we use a Car2DB Twitter map tool, it is great. It is an amazing tool. It is so simple to download the tweets. So downloading tweets itself is not such an easy task for journalists who don't have programming skills, and it also does the geo-referencing really well. The problem is this. They only sell this service to enterprise customers. And to be an enterprise customer, the minimum payment is almost $1,000 a year, which is a very, very expensive service for a lot of the newsrooms, especially if you're not doing these sort of visualizations every day. Certainly, we could not afford this at the Irish Times at that time. Okay, so this is a visualization of the same data set if we only went ahead with only geotagged tweets. So I'm going to show you the animation of it. It is not a very interesting visualization, so it is going to be pretty slow in the way it changes. So I'm not sure if you can see properly, but as you can see, nothing is actually happening there. So you will just sit there and get bored. And this around here is the moment of the only goal in the game. And still, this was the goal. And it's okay, but still not much is happening. So what we wanted to do was basically to improve that, to make it a more interesting visualization. This was the result of our visualization after we used our geo-referencing tool. And it's a completely different experience. So I'm going to show you, I'm going to put them next to each other. So here, as you can see, it's a whole different experience if we went ahead with only geotagged tweets, or if we actually do use our services for geo-referencing. And if I go to the moment of the goal, around the moment of the goal, it is completely different. So the flare is just huge. It's just completely different to what we had in the other visualization. So here I'm going to present how we did it. When we're talking about events in general, we talk about where, when, what, who, and why was involved in that specific event. And in this specific work, I'm going to present, we're talking basically about where, because we're talking about location. So what we did here was, because I was at the Irish Times, but I also was heading my own research group in Sci Center, we had already developed some Twitter geotagging tools for 2 of our projects. One of them was on, was called Social Repository of Ireland, and the aim of the project was to kind of archive and preserve social conversation around Irish events. And because we were only concerned with Irish events, we wanted to know which events are either tweeted from Ireland or are about Ireland. So location was very important for us. Another project that we had already worked on was a project that we have done in collaboration with RTE, which is the Irish TV and radio broadcaster. And the aim of the project was to give kind of breaking news alerts to journalists based on news that break on Twitter. Again, the concern was only for Irish news. Whatever is happening in Ireland, We were not interested in the things that, or the project was not about things that was happening outside of Ireland. So we had already been working on location detection with focus on Ireland. So we basically reused the same work that we were doing. So it was a very good example of where research organization and news organization basically come together to solve a problem. So in our approach, in TWILOC, as we call it, we propose to use various kind of features for location detection. The first one is geotag tweets, the most obvious one. If a tweet is geotagged, it's very, very accurate location information that we have, and we know exactly where this tweet is tweeted from. Only, again, as I mentioned, between 1% to 5% of tweets are geotagged. The other one is user profile information. There is two types of user profile information here. One is the profile information that I have on my slide, which is the user-defined profile bio location information. The other one is the location information that you select in your profile setting. And often you can choose a country in your profile setting. You also normally use or choose time zone and language information when you set up your own Twitter account. So those are other information that we use for location information. Then we kind of proceed to entity extraction and natural language processing. Again, for natural language processing, we do a lot of entity extraction. If there is an entity of location, we pick it up and basically we send it to knowledge bases, and we know that it is a location and it's in Dublin and it's in Ireland. The other way for entity extraction and NLP is if we have other types of entities, such as organizations or people, we can quite easily link it to knowledge bases such as Wikipedia and find the city or sometimes the exact location that they are located in. Another way is social network analysis. It kind of gives us an indication of where the location of my network might come from. In this specific work, we have not included it because it is not very specific with respect to the location that the tweet is tweeted from, and also it is very computationally heavy. So this is the workflow that we have used for location detection. First, the tweet comes in. If the tweet is already geotagged perfect, we have the location, the process is finished. If it is not located, if it doesn't have geolocation information, we send the text of the tweet for named entity recognition. If we find any named entity, we then send it for entity linking and disambiguation to other data sources such as Wikipedia, GeoNames, OpenStreetMaps. Location found, perfect. Location not found, or no named entity of type location. We look into user profile location information, the location information that you have set in your profile. If there was location information, again, good, we have the location. If not, we look into the biotext. And to look into the biotext, again, it is a free text field. So we need to, again, employ entity link, entity extraction, et cetera, to find person and organization entities. And then we find the location for them. If there was no location for that, we basically go to the next step. Oh, sorry, the previous one was in the text of the tweet, if there was any person or organization, and the next one is in the user bio information. If there was, so as you can see here, we are kind of going from very accurate location information for when the tweet might have come from to less and less accurate. So from the text of the geotag, from the text of the tweet, from the user bio, and we kind of end up to time zone and language information to see if we can get any information from time zone and language information. Time zone and language are kind of tricky because a lot of people have English as their language. So what we do here, if by now we haven't found any location information from the tweet or the person, and if they have selected their language as English, we completely discard that tweet. If the language is not set as English, then we'll look into the time zone and language information to see if we can get basically associate any location based on those information. Okay, very quickly, I'm going to present the results. As I mentioned, we had 22,000 tweets. Only 1,000 were geotagged. After running trilogs, 16,000 in our data set was geotagged. So from 4%, we managed to go up to 70% of the tweets, georeferenced tweets, which basically resulted in a much, much more interesting visualization. So at the end, we had on average 267 tweets per second tweets. So this is the process how we did the visualization. I'm not going to go through that. We also made a very, very small comparison between our tool and Car2DB Twitter map to see how we did. Car2DB, if you contact them and ask them for a trial, they're going to give you Am I back? Yeah. Lost you for a second. Okay. Okay. Basically 2 minutes left. Do you have my screen? It's doing some weird stuff. You got my screen? Stop and you got it. Okay. So basically, we just made a small comparison between our algorithm and Car2DB Twitter map algorithm. Car2DB from 8,007 tweets that we collected for Dublin Marathon geotagged for. Okay, and back. We basically check the system to see if this number of tweets that we have got is how accurate they are. We have got a very good percentage of geotagged tweets. We need to evaluate the results. That's more or less from me here. So if there are any questions, please.
Any questions about geotagging tweets?
We sort of missed the point of, so how were we able to verify that what you did was actually pretty accurate?
Okay, so I need it to be repeated maybe close to the...
Oh, okay. Close to where? Oh. Oh, well, okay. Oh, okay. Okay. How could you validate that what you got was pretty much accurate?
That's exactly what I was saying. Maybe I cut off that. We still need to evaluate the quality of the locations that we had. I did check a lot of the data sets for the football match, and I actually had to run a lot of tools on OpenRefine to make it more accurate because, for example, there was instances that Car2DB for visualization was not able to resolve the county names where the county name was as a location detected, and we had to run some tools, some rules to basically map the county names to the county town name or to the county city name, or sometimes the country that was detected, in my opinion, was not the best representative because, for example, when Car2DB maps the country, it maps it to the center point of a country, and we again I ran some rules to map the center point of a country to the most populated city of the country. But still, From the quality point of view, it is absolutely right. We still haven't validated, haven't checked the quality of if this suite was exactly the location that we detected for it was exactly the location that it was meant to be.
Okay, thank you very much.
Thank you very much.
Thank you.
Sometimes you try experiments and they work, sometimes you try experiments and... So, object lesson about Skype and talks for next time. All right, so one more session of the day. We have our closing keynote. We are very, very happy to have, actually, Chris, did you want to plug in? Or here, I can do that while. All right, so we're very pleased today to close off this meeting with a keynote by, are we okay? Yeah. Oh, he's going to presumably do something when it comes up. You'll show something in a second. No, it's okay. It's good. So we're pleased to have Chris Wiggins with us. Chris received his bachelor's degree in physics in '93, so this is our second keynote with a physics background. He got his doctorate from Princeton in theoretical physics in 1998, and actually just last year was elected a fellow of the American Physical Society. He's held positions at the Quran Institute and eventually ended up here in Columbia in the Department of Applied Physics and Applied Mathematics, as well as in the Center for Computational Biology and Bioinformatics, where he's an associate professor. At Columbia, he's also one of the founders and I would say thought leaders behind the Institute for Data Sciences and Engineering, where he also serves on the education and entrepreneurship committees. He's a co-founder of and co-organizer of HackNY. It's a nonprofit which since 2010 has organized once a semester student hackathons and the HackNY Fellows program, a structured summer internship at New York City startups. He's also the chief data scientist at the New York Times, a position he's had for a year and a half now. So Chris is a sort of a beautiful combination of someone with extensive machine learning expertise as well as someone who has tremendous exposure to and access to to journalists and to the process of journalism. So we're delighted to have him talk to us today about his experiences. Chris.
Thank you, Mark.
Thank you, Chris.
Yes. So it's true I didn't have my talk up, but now I will. Good. Thank you, Mark, for that long intro, and thank you to all of you for sticking it out until the bitter end. Usually I don't present this to audiences that are quite as familiar with journalism as this audience, so maybe I'll try to go quickly and then we can save time for questions, because this is an audience that will know more than most of the audiences I talk to about journalism. So, please? Oh, thank you very much. So, as promised, I'm Chris Wiggins, and I split my time between Columbia and the New York Times. I will try briefly to say why the New York Times has a data science group, what we actually produce, and then how a data science group can integrate into a larger company, and in particular to a large and old content company. So how did it happen that I ended up here? Well, as Mark was alluding to, my research is really in machine learning applied to biology, and that's been an extremely interesting and painful process for biology over the last 20 years to become a data-driven field. And I think it's also become, it's also a very instructive process, watching a field become data-driven. As one example, one of my favorite examples in biology, is this organism, Haemophilus influenzae, which was first identified in the end of the 19th century, and for about 100 years, this bug was studied by pouring bad drugs on it, and then you look under a microscope, and that's sort of how you understand the world. That's your experimental chance to interact with the system. And then suddenly in 1995, this became the first freely living organism to have its whole genome sequenced. So in 1995, suddenly you have multiple phone books full of information about this organism, which is in the form of just ACGT, GCAT, Gattaca, Tagacat. So that process of going from understanding a complex system for 100 years, using a kind of a limited way of understanding it, to suddenly having all the data you can eat and no sort of fundamental model to compare those data to, is a pain that I think happens in many other fields. And I think in media, that pain is happening now in ways that I'll try to expound on in a few slides. But I think it was a very instructive training ground to watch the biological community go through this process of becoming data-driven, and you now see it happening in many other fields. And so that gave birth to a field which we're now calling data science. I think that this cartoon definition of data science from 5 years ago is a useful one. This was a diagram put forward by a New York City data scientist named Drew Conway, who described data science as the intersection between machine learning and some particular substantive field of expertise that you are trying to apply machine learning to. And so many of the things that we do are trying to take questions that arise in the New York Times and reframe them as machine learning tasks. And I'll illustrate a few of the problems that we've worked on in the data science group. We tried to do that in a way that avoids the danger zone. The danger zone here means messing with data until you think you get the result that you intuited, or the result you thought you should get, and then you publish. We try to apply a bit of rigor to that. And then next happened is that I had a sabbatical. So I'd been applying machine learning in biology for about a decade when I took a sabbatical, and I asked many of my faculty colleagues what I should do for my sabbatical. And one of the faculty colleagues I asked was Mark, who said, you shouldn't go to a tech company or to another university. That would be the same thing you always do. You just would be doing research in a different desk. Instead, you should go to the New York Times. It would be weird. And so I did, and it has been. So the New York Times is not traditionally thought of as a data-heavy experience. It's traditionally thought of as a media company. In fact, it's most of its history has been a print company. Here's the first page of the New York Times from 1851, 164 years ago, instantiated as the New York Daily Times. And the dominant org chart, just to give you a sense of where the data science group sits in the New York Times, the dominant org chart for all media publications for the last century or so has been church and state. And church is where the journalists are, the people who keep and defend the craft of journalism, and state is everything else, sometimes called the business side. And so just to clarify where I am solidly in state. That is, when I tell people that I'm a data scientist at the New York Times, they say, oh, I love the Upshot, you guys do great work. They are great, the Upshot, they're wonderful, they do great data journalism. I'm not in that group. Those people do things that are public facing. And they're awesome and they share their code on GitHub, which I think is great for reproducibility. Or I tell people I do data science at the New York Times and they say, yes, I love the interactive pieces and I love the graphics. And I say, yes, those people are great, they're awesome, high five, props. I'm not in that group. So just to clarify that I'm not on the church side, I'm quite solidly on the state side, and in particular, I'm in the engineering part of the state side. So you may not think of a publication as needing an engineering team, so I want first to spell out to you how it came to pass that the New York Times has a pretty large engineering team. Really, that was one of many unintended consequences from the creation of a website, from the joining of the New York Times to the World Wide Web in 1996. So the New York Times has had a website for a while. The website was launched on my birthday in 1996. The New York Times reported on it with this quaint headline, "The New York Times introduces a website." And many unintended, the story of technology is the story of unintended consequences, right? You think you're building something for some reason, and totally other things happen as much more important and high impact consequence of that technological innovation. Now, and by now I mean about a year ago when I took this screenshot, now millions of people go to the website every day. There's tremendous abundance of digital interactions. And what's exciting about digital interactions is not just that you are putting you're using a different channel of communication, it's that digital interactions are actually communications, right? They're actually conversations. So when you have a radio receives photons passively, and then it amplifies those photons and it projects those to somebody who's listening, but it does not tell the radio station anything about the way that you engaged with those photons that appeared in the radio, right? Or a broadcast television. In contrast, when you issue an HTTP GET request, which is to say every time that your browser points or clicks or scrolls or on mouse overs or whatever, you are actually having an interchange with some web server somewhere, you're having a dialogue, and if that web server so chooses, she or he can record that interaction, right? Unless you think that there's a lot of information given up every time you point and click, I assure you you're giving up far more information every time you use a mobile device, right? And you open up the possibility for many large tech companies to really serve you well by listening to you at scale. Without violating NDA, this is what you see if you open up Google browser and you go to the developer tools and you go to the network tools, you can watch what sort of information you're sharing with any website. So you go to a website and you're telling them what browser you're using, your IP address, your operating system, where you were coming from, how long you've been reading in seconds, how many characters you've scrolled through roughly. So what's an unintended consequence of putting out a website is that you're not just making an online presence, which is, I think, that's the way many companies felt about the World Wide Web in the late 90s this was going to be our online presence in addition to our brick and mortar presence or our print presence. It's really a microscope for trying to understand all of your audience at scale. It gives you a chance to understand your audience in a much deeper way. And as I think somebody was saying yesterday, you can ask people a bunch of survey questions, but how they respond to you on a survey is not necessarily nearly as representative as actually watching them use a product. And when your product is a digital product, companies now realize that that's an opportunity to observe the way they use it at web scale. It's also, as I think Lada might have mentioned yesterday, or maybe not, an experimental tool, right? That is, if you so wish, you can show some of the people a blue button and some of the people a red button, and you can learn which is the better button to be showing people, which is another way of saying any digital product is also potentially an optimization tool. If there's something that you're trying to get right with your customers, all those decisions that you make when you are trying to get it right are digital decisions. Those are decisions implemented in code. And so there's many opportunities when you go to a digital product to try better to serve your customers, or in our case, the readers. So that is how you might want to have a data science group, is because you have the opportunity to collect abundant data. Now then, why might you want to create a data science group? Well, I assure you, for the New York Times, this is not a mere academic exercise. By academic here, I mean a research exercise, which is fun, but not particularly related to business. So let's zoom in on another unintended consequence of creating the World Wide Web. In the mid-90s, we can look at the spend on advertising in the United States, 1950 until very recently. And that is a chart that shows a clear trend, right? Like if you're working on modeling complex systems and you see a chart that has this trend, you know that you have found something that's not just noise. So this trend is national spend on advertising year by year since 1950, and you can see that something tremendous happens 2004 through today. And that's even before the decline of the economy in 2000, 2008. It was a massive shift in the way advertisers choose to spend their money. How is that related to journalism? Well, the craft of journalism has, over the last 100 years, become quite tightly coupled to the business of newspapering. And the business of newspapering has had as its main income source advertising. Right? So a tremendous thing happened to journalism, therefore, 2007 through today, as advertisers simply stopped spending their advertising money on newspapers. Right? So in the late 90s, it was good times, and then people stopped spending their money. So what you've seen happen in journalism as a business in the last decade is a real change in their understanding of their business model. So I like to invoke Steve Blank's quote for what is a startup. Steve Blank says a startup is a temporary organization in search of a repeatable and scalable business model, and under that definition, every publisher is a startup, not just Vox, Vice, BuzzFeed, right? Even legacy, old school publications are in the search for a sustainable business model. We do not know yet as a species if journalism has, in 2015, a sustainable business model. We certainly hope so. And we are in the experiment to find that. To zoom in on some of the digital sources in the last couple of years, you can see that part of the shift in spend was not just that people stopped spending, but they stopped spending on newspapers, including print newspapers, and started spending on other sources, including here, Google, Facebook, a few other sources where the trend is up and to the right rather than down and to the right. So the New York Times is not interested in having a data science group as a research project per se. It's interested in trying to conduct the experiment of finding out whether or not journalism has a repeatable and sustainable business model for the future. And that is what we are focused on in my group. New York Times, as you probably know, this group knows, is not putting its head in the sand, which with respect to the challenges of innovation, you can read all about it in this 96-page document, which, as this audience probably knows, first appeared leaked in BuzzFeed in May of 2014. It's an excellent document about innovation in general and also the innovation challenges at the New York Times. One of the recommendations of this report was that in the church and everything else org chart, we're missing an opportunity to bring some of the groups to bear in both the church and the state operations. And so it's been useful to be sitting within the engineering group as more and more of the process of the New York Times becomes in code, becomes run by software engineering, and to find ways to be useful both to church and state using the data that we gather. So one way, let me say a little bit about what we actually do. That was a bit about why you might want to have a data science group. What are the things that we actually produce? We try to focus on different types of modeling, and I like to break up the things that we do into descriptive modeling, prescriptive modeling, and predictive modeling. So descriptive means we have a bunch of data. How do we make those data comprehensible and interpretable? Predictive modeling means there's something that we're really interested, usually in the future, and we're trying to predict that from data that we can measure easily. Prescriptive means we're actually trying to suggest to some human being, here is what the algorithm recommends you do next. So predictive, descriptive, and prescriptive modeling. Where are there examples of predictive modeling on the business side of the New York Times? Well, a pretty obvious one, and one of the first ones we worked on was simply, if you watch people pass through the funnel, which is, you can read about this in the innovation report, the idea that some of the people never use the New York Times, then they encounter the New York Times the first time, then they become regular users, then perhaps they become registered users, then become subscribers. How do we go about predicting who is going to make that next transition to the next step? So that's useful. So I should say, in addition to making the progression to become a renewer and then a loyalist, of course there's another transition, which is you might leave. So you would like to predict those transitions, right? Subscribers might cancel their subscriptions, right? And that sort of has an engineering win if you can predict who's going to leave, or a business win if you can predict who's going to win. But it also has a science win if you can figure out why. If you can figure out what are the really interesting covariates, or the interesting user attributes, or the interesting features of the product that people engage with that seem to correlate with becoming a subscriber, you might want to make a change in your product or make a change in your marketing. And that's the kind of things we've been trying to do in concert with people in product and marketing. This is actually not that different than things that one does in biology. You might try to build a predictive model, but you would like to go and rank order the features and say, well, some of these features are clearly very good. Like, I'll put these features in green. You want more of this feature to happen in the people who are becoming subscribers, and some of the features are bad. It is bad if people do this. They're more likely to become, to cancel their subscription, or they're less likely to become a subscriber. Again, this is not very different than what's been happening in biology in the last 15 years, where you have a bunch of genes going up and down. For all those genes, you have regulatory elements, little sequence elements that you think control what makes the genes go up and down, and you would like to learn those, and you would like to say to the biologist, here are the things that I think are the control knobs, the things that might be causal for making these genes go up and down. Another example of a prediction problem is the New York Times actually, unlike many publishers these days, the New York Times makes newspapers, right? And so you might want to actually predict the right number of newspapers that go to the right place. That is a problem that's actually getting more and more interesting as we acquire more and more data about how many copies of the paper were sold at every store. I can't tell you in detail what models we used, and I definitely don't want to tell you actual orders of magnitude in monies we can make, but just to assure you that things are in fact going up and to the right, you can make more and more accurate models about how many papers you should be distributing to all these individual stores. Recommendation is another thing that's a predictive task. You can achieve recommendation in many different ways, and all of you have probably seen at the lower right-hand side of the homepage a little recommended for you box. If not, I encourage you to check it out. There are many strategies for doing this. Alex Spanger in my group, who's in the room, wrote a blog post recently about a way of doing this using a technique called collaborative topic modeling, which was proposed by my colleague Dave Bly here at the Data Science Institute, in which every story is represented as a mixture of multiple topics. Every user, or every regular reader, is represented as a mix of affinity for different topics, and then we try to connect different people with different stories that are associated with those topics. And if you'd like to know more detail about this, I've made a short URL so you can go read the blog post on that. Descriptive modeling. So those were all things where you try to predict what's going to happen. Descriptive modeling is a large class of what might you do when you have many data. For example, trying to segment people into different groups. So it may be that you get a bunch of data about how somebody uses your site, but really you want to say, well, this person is from cluster number 14. So that is a task which typically people do if they have many, many users and they would like to say something more nuanced than simply, this person is a millennial or this person is a baby boomer. You'd like to say something more substantive about the way they use the product. Dale Kim, who's in my group, who's finishing a PhD at Brown, has been developing descriptive approaches to try to understand how different people in different countries engage with different types of content. He's been using a technique called Bayesian non-parametric modeling, which essentially says, documents are themselves mixtures of content. People are associated with mixtures of topics. How do we go about modeling things in such a way that we can associate different people with different topics with which they like to engage? And that provides a way of modeling your audience. Prescriptive modeling, as I said, is different than simply predicting what's going to happen. You actually want to say to a human being, I recommend that you do some particular thing. One particular example of this you might have read about from Neiman Labs is a Slack bot that we built called Blossom. So Blossom was built by somebody in my group who's embedded in the audience development team in the newsroom. Audience development as a team is charged not with crafting the journalism, but with the task of getting our good journalism in front of as many people as possible. That is, we want our stuff to be read, as Dean often says. So one of the things that you can do to make sure that your stuff is read is to promote it variously on the abundant set of social channels available to us. Twitter, Facebook, Snapchat. Tomorrow it'll be some other Snapchat du jour. But in this case, you might ask Blossom, what should I be posting on Facebook? And Blossom will make recommendations to you. Here is a thing. Here's a URL that Blossom bot recommends that you post on Facebook. So on the back end, that's a machine learning problem. But on the front end, just in terms of human-computer interface, the editors of the New York Times spent a lot of time in Slack. So we tried to make this a friendly Slack bot that you could interact with without leaving Slack. You could simply ask Blossom bot, what should I be promoting? And Blossom bot also gives alerts, which is clearly a prescriptive thing. Blossom bot is saying to you, here's a story that we think you would do well to promote, and might call out to you while you're in the middle of your life, your usage of Slack. How do you integrate something like a data science group into the process of a company? And again, the New York Times is a newspaper. Well, it's a media company, but it is also a company. So when you do descriptive modeling, it may be because you haven't made a product yet, or you haven't made a marketing campaign yet, and you simply want to have some understanding of who are your readers, right? And you'd like that understanding of these people are baby boomers, these people are millennials of different types. That might suggest to you what sort of marketing campaign and what new products you might come up with. Once you've had a new product launch or a new marketing campaign launch, then you can watch data observationally and try to build predictive models. I can try to correlate some attributes of the way people engage with something that I want. For example, I want people to become subscribers, or I want my subscribers not to leave. Once you have some idea about what covariates are interesting, then you can start doing testing. That is, you can try to optimize different possible choices, different design choices, or different product choices, different marketing choices. And at some point, once you really know how everything is going, then it becomes the way that we have always thought of data as part of a company, which is reporting. Right? Once you know what the key performance indicators are, once you know what are the numbers you need to be observing, then you report to senior management, the ship is sailing straight, or not. Right? Whatever, the reporting task is not something for which you necessarily need a data science group. And of course, things don't really happen linearly. The way things really happen is you constantly refine your understanding of the world, and as the ship suddenly doesn't sail straight, then you might want to dig deeper and try to understand why. You might want to look back at predictive modeling or optimization. So that was a bit about what the New York Times, why the New York Times might have a data science group. Let me say a bit about how a data science group integrates into a company and I think it's useful to keep in mind something that people in the US Air Force say, which is that if you really want to get anything done, you need to bring together people, ideas, and things in that order. So first, let me focus on the things. What are the things that a data science group produces? So we try to focus on building simple prototypes. That is, when we are doing some exploratory machine learning, it's not very interpretable if you say just publish a report and say, here's my loss function and here's my area under the curve. It's much more interpretable if you can build some simple prototype that people can interact with. And I think that's generally true, whether the people that's interacting with it is an editor, a journalist, or a four-star general, or some other non-technologist, or somebody from outside the machine learning community. It's very useful to have some prototype that you can interact with. We try to build APIs. So APIs, application programming interfaces, are programmatic ways of interacting with the output of some research so that you can do something that's not just a deck or a report, but something that becomes a tool that other engineers can call and they can integrate into their processes. Impacting roadmaps really is a much more abstract idea, but it's the idea that you're able to say to another group somewhere in the company, here's what we learned about the way your function works, and we suggest that you do things differently. Right? If you actually convince somebody else that they should change the way they're doing what they've done, you know that you've had an impact on the process of the company. Data prototype. So an example of a data prototype, again, this is not a New York Times specific one, except that it was built by Dale Kim, who I mentioned, who's in my group. Dale built this Knight Foundation funded project to take a corpus of text, analyze it in terms of the component topics, and then render that in a way that people can interact with. And he's built similar applications in Flask. Flask is a web dev framework for Python to try to help editors and journalists and designers understand the way different groups of people interact with different groups of content. Building an API. If you've never seen an API before, here's a simple one from nsawatch.me. You can go hit this URL and say, I want the API and I want 8 sentences, and it will tell you 8 sentences that will put you on the NSA watch list. Just a bunch of bad words. But the idea of an API is to have something that's programmatically available and with such a simple syntax that it will be useful for engineers or technologists more generally throughout the company. So for example, one of the things going on in our group right now is Nick Ursa, who's part of the team, is building a retention API. Actually, he's launched a retention API so that people inside the company can hit this API and get, for different subscribers, a score or some sort of measure of, how at risk is this person? Does this person look like they're about to cancel their subscription? And that can be used by marketing, product, or we're not even sure what other uses we might have for that. Impacting roadmaps, as I said earlier, is sort of a business decision, is business speak for people have to make decisions about what they're going to do in the next month or the next 2 months. And when they set that out, that's called a roadmap. And you impact somebody's roadmap if you find some way of understanding what their process looks like, what their corporate function looks like, and you change what they decide to do. In that sense, you've had a useful data science group. You've had an impact on the way people run the company. So those was a statement about the things. One thing that I think is useful, or that we found useful in building a data science group and actually integrating into the process of the company, is a set of ideas as the field of data science becomes more nuanced. So every year, I think people are using data science as a phrase in a way that's more well-defined, and they get a better sense for how data science as a skill set integrates into other skill sets. So some things that we found useful to distinguish when the data science group is between the data science and the data engineering. So the data engineering, we consider the parts about how you deal with abundant, large data sources that are usually on distributed systems. So the team that we work alongside is called the data engineering team. Those are people expert in setting up a Hadoop system or a real-time streaming solution for getting the data that we wish to model. We sit alongside a data visualization group, which is very useful for trying to make our results useful and interpretable. We work closely with people who are product thinkers. So data product is a special type of product management where you need to think about how do we maintain and monitor something that's actually statistical. It doesn't simply stand up or fail. Sometimes we need to think about whether the results make sense. And also a data product thinking is how are you going to integrate into somebody's process something that's a prediction or a prescription. So for example, in the Blossom project, we had there's a lot of work thinking about how we go about interviewing people, in this case editors, growth editors, and try to build a product that's useful to them and not disruptive to how they work. Multiliteracies is an idea I cribbed from Mark Hansen, who in turn cribbed it from Charles Selber, I believe. The idea that we have a data science group that is functionally literate, right? They are able to write code and produce data science results, but we can also be useful to the company by encouraging people to be critically literate or rhetorically literate. That is, I want people to be able to be skeptical when they hear a statistical result, and when I produce a graph, I want everyone in the company to be able to know how to use that graph to tell a story. I want senior management to have, well, I haven't tried an RLC curve, but some curve that comes out of our research and have senior management know how to use that curve to make decisions and tell a story. And the last idea that I think has been very useful for our team is data embeds, and by that I mean taking a data scientist and instead of putting her or him in the basement and disconnected from the process of the company, to put that data scientist on a desk sitting with people who are trying to get something done, learn their process, and make sure that they're producing results that are useful to people. So we have one data scientist who's embedded in the audience development team, another data scientist embedded in the personalization team, another data scientist embedded in the new markets team. So in general, we try to take people, and although they're still part of our group, and they come to our weekly data science group meetings, they spend their time sitting alongside people who are going to be putting their data science to work. Right, so data embeds we found particularly useful. But as I said earlier, the difficult thing about a culture change, you think there's some technological thing that's going to make it all happen, like you just get the right Hadoop and then everything falls into place. Really, you don't impact a culture change unless you have people and that they have a different mindset, that they're willing to make it a habit to give data a seat at the table when they're making difficult decisions. And so we are fortunate that we have, that we're working in a company that has been sufficiently challenged that it is willing to adopt a new mindset, a new data-driven mindset. And as I said earlier, really what you need is people. And so we're fortunate that the people at the top have been willing to bless the creation of a data science group, to integrate that data science group into the larger engineering structure, which at present is about 500 people, and to make sure that data science is given a voice in making difficult decisions that you make every day when you're running a company. And of course, when I say we, I mean they, right? When I say I mean we, and they did all the work. So let me thank the people who did the work. We've been fortunate over the past year and a half to build out a data science team. Alex is here, he's embedded in the personalization team. Pardon? No, the dog is not actually part of the data science team, thank you. People coming from diverse backgrounds in pure math, astrophysics, computer science, and many of these people, as I said, are actually embedded in different parts of the company, making all of these results possible. And with that, I think I'll close, because as I said, this is a very literate group, so we should get to some questions. Thank you, Mark.
All right, do we have questions? Thank you, by the way, that was awesome.
Thank you for inviting me, Mark.
Questions? Yes, sir.
A while back, the Times began charging online, and I heard it was a discussion of how to charge, how much for what things. Was that decision of how to charge and how much made with help from your group? And also, are they now making money finally?
Yeah, so those are both easy questions to answer. The data science group was only created about a year and a half ago, and the paywall went up in spring of 2011. So although there was certainly numbers brought to bear in making that decision and setting price points, and that's a conversation that continually is reevaluated, no, that was causally. I can claim no credit for that. And the second question, are they making money? Yeah, absolutely. At this point, the company is making hundreds of millions of dollars from purely digital. The company recently passed the million subscriber mark for digital subscribers. The CEO likes to say that at the time, everybody said it was a bad idea, and we have found a way to make it work. So yeah, that has been one of, as I said earlier, when you are confronted with a real change in the underlying business model, you need to experiment. And I would say that is one of many experiments that the New York Times has engaged in the last 5 years to try to explore possible sustainable futures for journalism.
Great stuff. Thanks, Chris. I'm sort of curious your experience in dealing with sort of the norms and the ethics that are part of journalism and how that might influence what you're doing or inform what you're doing or lead to tensions around the use of data for different things. I mean, historically, journalism is about making tough editorial decisions about when it's right or wrong to publish certain things. The way that data is used in various ways could be used for better or worse. And I'm just curious to hear your thoughts on where those kinds of tough editorial decisions or ethical decisions might sort of come into play with the data science, engineering, et cetera.
Mm-hmm. That's a very broad question. Thanks, Nick. So, I mean, decisions about what is to be published. First of all, I can say safely that I have never participated in any of those decisions, and I haven't seen any evidence whatsoever that the New York Times is making decisions about what is and is not to be covered based on any data, right? I mean, people at the New York Times have a strong sense of news judgment, right? They have a strong sense of what needs to be covered, what should be covered, and I don't see that being challenged by data anytime soon. Part of the way I tend to think about it is that I like to think about the first two paragraphs of the innovation report. So the first paragraph, first paragraph is the New York Times is winning at journalism. First sentence of the second paragraph is something like, we've not kept up with the art and science of getting that good journalism to as many readers as possible. So most of the things that I'm touching on are either straight business problems, like how many copies to send to store number 43 in Washington, D.C. tomorrow is not something that's going to violate news judgment. Or for the newsroom ones, it's more like, how do we make sure that this good journalism gets to as many people as possible, or to its natural audience, right? How do we promote this story, right? And the audience development conversation I see as separate from the first paragraph, which is data somehow impacting the editorial decisions that people make?
But isn't there, sorry, just to jump in, isn't there a gray area there when you start sort of rank ordering things fall off lists, things like...
Good, thank you, Mark. So keep in your mind two different things. I like to think about the quote from Albert Einstein at this point, not everything that counts can be counted, and not everything that can be counted counts, right? So keep in your mind two different things. One is, what are the things we can quantify? And the other is, what are the things we can quantify that we're going to use as the basis for decision making? For example, how are we going to reward different reporters? Or how are we going to evaluate different reporters? So, the perennial conversation about the Gawker big board, right, with the idea of evaluating journalists based on some quantitative metric, it's not that Gawker invented counting, right? So there's a technological fact that you can count the number of people who viewed something. The question is it a good idea or a bad idea to use that in your management? Should you evaluate people based on these metrics? Fortunately for the New York Times, I think the New York Times is quite solidly, they're able not only to count, but to read. So I don't see any danger that the New York Times is going to start evaluating its journalists based on these metrics. It is not the case that we are going to go back to a history in which we do not know numbers, right? There are plenty of companies, including some in the room, that will help you, quantify the number of people who are viewing a page at any time. We're not going to go back to a history to a point where that doesn't exist. The question is, what are we going to do with that? Are we going to do difficult thinking, like what is it that we should do? How valuable was this piece? Or are we going to do fast thinking, like easy thinking? Just tell me a number. Which one got the most numbers? And the experience I've seen at the New York Times is that, as I said earlier, people can not only count but read, and they have their heads on straight about the fact that just because you have these numbers doesn't mean that you should use them for the really important decisions. That's my sense. Please.
Hi. Thanks for the talk. Really interesting. So especially in certain areas of machine learning and artificial intelligence, now most of the cutting edge research is performed into companies in research labs like Google. Do you ever see a company like the New York Times, for example, eventually develop its own research labs where you guys publish stuff?
Well, we have it. So there is an R&D lab. There has been since 2007 or so, and I think Mike Dewar was on a panel earlier this morning. So the New York Times has an R&D lab, and have we published in the past? I don't know if we have published in the past, but we certainly have permission to publish, and I anticipate we will be publishing in the future. Please.
Hi, thank you for your talk. It's really fascinating. So earlier today I was telling a story about some negotiations that I've been working on to get access for researchers to do text mining of current news. So what do you think of the business model of having like a secure virtual server that researchers could go in and run text mining projects at New York Times, for the New York Times? Because I know there's a lot of people that would love to do that.
Yeah, so the New York Times already does quite a bit of this. So the New York Times already released for academic research a very large corpus of the archive. And the New York Times has had for many years an API. I feel like the New York Times was one of the first companies to have, just a public API where you could search its articles. So if you go to developers.newyorktimes.com, you can read about the API, and I can point you later to where you can find information about the archive, or introduce you to the person who maintains the archive. So the New York Times, I think, has historically been quite open about all of that.
Go ahead.
Yeah, so your title says how a 164-year-old content company become data-driven, but you're at the state part of the content-driven content company. So your data-driven is mostly about a data-driven business. It's not necessarily data-driven journalism here, at least your topic today. So how do you, if we talk about business, so there are two parts, how do you think the success or the value of New York Times is perceived as the content or perceived as its business? That's the first part. The second question is, generally or philosophically, how do we value or price like intangible products like articles, like content? How do we price them?
Mm-hmm.
Yeah.
Yeah, so I'll agree with you that the parts that are data-driven now are quite solidly on the business side, by which I mean the set of things that are not impacted by news judgment. Another way that I sometimes say it is the most important decisions that the New York Times makes every day are the decisions for which news judgment is relevant. Of the remaining large number of decisions that the New York Times as a company makes, there's plenty of those decisions for which we can bring data to bear. In terms of how you value things, the New York Times has a business model which would not be well served by making the journalism data-driven, right? And so it would both be anathema to the people who actually are on the church side, right, who are keeping the craft of journalism, but it would also be bad business. And I say that because, algorithmically generating articles is something that anybody can do, right? Algorithmically choosing from a variety of different news stories, or algorithmically observing the internet and then writing some content or aggregating somebody else's content, putting a news story around it and linking it. That's something that other people can do and are doing, right? So it would literally be bad business, in addition to being contrary to news judgment, to start doing data-driven journalism, right? And by data-driven journalism here, I mean algorithmic journalism. So I don't think that's in danger. And in terms of how you value things, that is really a question of how you establish a brand of trust. Like, how do you establish that people trust what you say? And that's difficult to value, whether you're talking about the New York Times or Columbia University or any other, multi-century institution, right? So, I mean, that's why you have people making the most important decisions, right? That's why you have people making the decisions for which news judgment is relevant. Please.
Great work, by the way.
Thank you.
I want to share an experience that we see in the healthcare field, but I think it's also relevant with what we're doing. What we see in Europe, the couple of few years, is that we see a lot of patients who are reluctant on sharing their data, their information, their medical records, because of a lot of misuse or even abuse of their privacy. And we see that even countries, especially Germany and the Netherlands, are getting more and more concerned about sharing and privacy and securing the personal information of their patients. I'm currently thinking that a lot of your work is based on the fact that data is abundant and data is being shared and personal information being shared. Are you concerned that maybe in the coming years, a lot of people might turn security much higher than the freedom of sharing data? That if people are starting private browsing, if people are starting being more concerned about the data they share, with especially corporates, do you think that this might also affect your work? Are you concerned that maybe we're going to end up in a future that maybe people don't want to share so much information, and be more skeptical about what is being disclosed to other parties, to corporate parties, and how this could also affect your business?
Yeah, I don't think the future of journalism depends on the extra 2 or 3% accuracy I can get for these things based on knowing not only the IP address, the browser, the operating system, but also the browsing history. And the data that I have, like a couple of clicks, is nothing like being able to read all your email, right? I mean, it's a very small amount of data that the New York Times or any other publisher is actually gathering and recording. As far as whether or not people get more concerned about privacy, yeah, I anticipate they will. I mean, this is part of how any technology becomes part of human process, right? Like, you introduced the Model T in 1914, and it takes another 60 years before people have seatbelt laws, right? Like, you introduce a new technology, and it takes years and years for people to realize the unintended consequences of that technology, including consequences that are like bad for them. I think seatbelts is a great example because, when you have a car accident and you're not wearing a seatbelt, it's really like visibly bad. And yet it still took decades for people to do anything. How much more visibly bad is that than some of your data got leaked, right? Some of your data ended up at a 3-letter agency or ended up in a different country, right? It's literally not visible to you. In fact, the only people who are talking about it is if it gets exposed in the press, right? So I hope people start taking their data privacy more seriously. I think that that's just really just a common phenomenon of the way new technologies become part of people's daily lives. But I don't, in terms of my personal contribution to saving democracy by trying to, help making these business processes more efficient, I don't think the small extra bonus from having not only, bare information about a first-time user, but also a couple of clicks from prior stories, it's not an order one loss.
Thank you.
Sure.
Okay. Hi. Thank you for the talk. My question is, all newspapers started from print news, so you have limited space, and every article could have to fit into limited space. And now on the web, you have unlimited space, so you can have the complete interview with some people, whatever. It doesn't have to be limited by space. Right. But now on mobile, again, you have very limited space. Yeah. And I feel like when I find something interesting, I just save the link, but I never get back to that. Yes. And then I just engage with the title of the news. So can you comment on how these different platforms are also changing the way the journalism is led?
I agree with everything you just said. So you're right that I experienced this as a researcher and a publisher in academia, because when you publish a paper, when I started publishing papers, you were really limited by like a four-page limit was a big limit for some of the journals I was publishing in as a young person, by which I mean a graduate student. And those were like the right journals. So you had to somehow squeeze everything you wanted to say in 4 papers, which is crazy for anything of substance. Now, you're right, with online supplementary materials, you could just put as abundant materials you want online as part of a research paper rather than just the 4-page limit. Also true with journalism. That said, journalists in general are on a deadline and they need to get to the end of the story, and at the end of it, they don't necessarily want to invest time to make all the code commented and reproducible, distribute the entire archive associated with the journalism. We as a species, I hope, will find mechanisms that incent people to create a whole archive associated with everything created in investigative or other journalism. Bracket that. And you're right, also I agree with you, that the experience of reading in the palm of your hand is very different than, on 5 pounds of dead tree that you can spread over a big table and really investigate over multiple hours. It's a very different user experience. We have, as a species, optimized the user experience for reading on, broadsheet dead trees. We haven't yet optimized the user experience for reading and engaging with news in the palm of your hand. I also myself find that I send a lot of things to Instapaper and then just never read it later. So I empathize with that experience. But I guess the short answer is, I assure you that the New York Times is not unaware of that, and Dean Baquet talks regularly about how, among other experiments that the New York Times needs to use to experiment with, is how are we going to continue delivering the report, right, that we feel is dutiful and that our readers expect when it is being engaged with in the palm of your hand, right, an incredibly small surface area compared to the surface area that journalism has been co-evolving with for the last century. So yeah, that is definitely part of the New York Times experiment, and there's a lot of ways that data can be useful there for making sure that on that small real estate, the things that are most relevant to you are delivered to you now. Many companies are now exploring that.
Hi, Chris.
Hi, Kathy.
Very interesting.
Thank you, Kathy.
I'd like to better understand your distinction between predictive recommender systems and prescriptive.
Sure.
So I usually think of prescriptive as a set of rules for what you should do. So a grammar is prescriptive, for example. So what is the distinction?
Yeah. So there's a couple of fields where it's partly it's a statement about how you put machine learning to use. Partly it's a statement about the character of the covariates. So to the first answer, consider the case of reinforcement learning or machine learning and health, right? Like if you're doing reinforcement learning, you actually want to make the robot do something. So it's of interest for the robot to be able to take sensory input data and predict, oh, this is a room or this is a chair or something. But what you really want is to suggest an action to that robot, right? And often the thing that you're trying to optimize is not minimizing L-squared error or maximizing likelihood. You're actually trying to maximize the reward over all possible actions you can take given the state of the world that you understand, right? So this naturally maps onto the framework of reinforcement learning, for example, different from supervised learning, different from unsupervised learning. The second way to distinguish it is the character of the covariates, because often when you have observational data about the world, one of those columns, one of those covariates, is a column describing an action that you took. For example, you've got healthy people, and some of those people received a procedure or a treatment, and some of them didn't, right? The case control variable in the case of all medical informatics for the last century, right? So those things, those analyses where you analyze a data set about response, case control, and everything you know about the user, there's one column that's particularly of interest. And the reason it's of interest is because you're doing that analysis in order to suggest to future people, given the state of the person, what is the action I can take that will maximize the reward? So that's what I mean by prescriptive is, in part, it's a statement about how are you going to put the machine learning to work. If you're going to do it for engineering or for health, you actually want to suggest to somebody what action they should take. But partly it's just a statement about the character of the covariates. If there's one magic covariate that you have control over, but most of them you don't, right, then you're doing that because you want to prescribe to some people what value of that covariate should you set to maximize some reward. So I like reinforcement learning as a framework for this because you're not trying to maximize likelihood or minimize L2 loss, and generally you're trying to maximize a reward over all possible actions given the state of the world. So in my particular case, it's something like you have hundreds of articles that are put out by the New York Times every day. The New York Times is only going to post to Facebook a certain number of them. How do we go about saying to the growth editors, here is an article that we particularly think you would do well to post to Facebook, right? Or in the next half hour, here's an article that we think that you should post to Facebook. So it's a particular action we'd like to suggest. Yes, please.
Hello. So I read online that the total cost of maintaining the newsroom of New York Times is about $1 billion. And you just said that the number of paywall subscribers is 1 million, which means about 100 million in paywall revenues. So I wanted to know to what extent is the paywall a sustainable news model to maintain the expanse of New York Times newsroom as it currently thing, or do you need to look for other streams of revenue as well?
That's a great business question. Don't forget that there are also print subscribers. So I don't think I included the figure in this deck, but you can go look at the innovation report and you can see that at least at the time of the innovation report was published, the majority of the money is coming from print, both in subscription and in both circulation and in advertising. So digital is good, and the print provides cash and control and sort of a slow burn rate as the company experiments with a whole portfolio of likely digital options. We're definitely not at the place as a company now that you could simply cut off all of the print and things would continue at current level, right? But fortunately, print is not declining so quickly that we don't have the time to experiment with what a sustainable business model will be for the remaining part of this century. I'm going to defer to the expertise of somebody who was previously paid on that.
All right, our last question comes from our first speaker.
Oh, hi, Chris. I was interested in your perspective as a data-driven person when you're reading articles. One frustration I've had is that, you know, two articles will start out the same way. A mother is playing with her child at the park, and then one of them will go on to get quotes from a bunch of parents, and then the article will end. And others will quote studies with data backing them, or it will actually be data analyzed by the New York Times. And I feel very frustrated that there isn't a label that says this article is data-driven or contains data. What's your perspective for readers who, you know, might enjoy both types of articles, but for some subjects, they care about things that are data-backed as opposed to not?
Right. So although it's not perfect mutual information, there is one label that's informative, which is the upshot. Right. So there is a data journalism group at the New York Times, and if you read a story that says the upshot on it, it's probably going to have lots of data in it, and it might actually be on GitHub. As far as the other kind, you know, sort of shoe leather work where you go and interview a bunch of people and construct a story, but you don't necessarily have, it's not necessarily computer-assisted reporting. I'm not aware of a label on that that is accessible externally. Certainly internally, if you hear somebody say enterprise investigative journalism, that's somewhat different than computer-assisted reporting, which may have a large database behind it. But I'm not aware of a public-facing flag yet that would help people grep out the articles that don't have data behind them.
All right, Chris, thank you very much.
Thank you, Mark.
All right, and with that, I think we bring the fourth Computation and Journalism Symposium to a close. Thank you very much to the audience who have come to attend, our students, to the people who have submitted papers. The papers were excellent this year, thank you, and to our organizing committee who read through everything and helped pull all this together. And again, I can't thank enough my deputy, Michael Krish, who made all the logistics work happen. So thank you all for coming, and look for us next year. Thank you.